This 6 hours long masterclass is your one-stop solution to master AWS fundamentals for the data domain. There are hundreds of services in AWS and beginners do not even know what services to learn, what not to learn, and in which order to learn. And then they just get frustrated and simply quit learning. But do not need to worry at all because I have created this step-by-step guide for you which will cover everything from scratch, including what is cloud computing, AWS service models, virtualization and hypervisor, AWS EC2, AWS IAM, AWS S3 buckets, roles and access keys, AWS SDK, AWS blobs, AWS Glue, AWS Lambda functions, AWS triggers, AWS crawlers, AWS Athena, and much more. In short, by the end of this masterclass, you can confidently say that you know all of the services which are related to the data domain. And you know what? You're gonna enjoy the learning with this video because I have explained everything visually with cool graphics so that you can enjoy and have fun while understanding the concepts. And all the notes are provided with this video for free. So just enjoy. And you know what? Your one like and comment actually brings that big smile on my face. And thank you so much for showing your love on this video. I am really excited to kickstart this masterclass and I want you to crack your dream job offers this year. So let's get actually started with this masterclass. So what's up my fam? Happy Sunday. So finally we are here with amazing masterclass because you were requesting like Ansh Lamba, we want to learn AWS for you, we want to learn AWS from you, we want to learn AWS for you. So finally now you can learn AWS from me. So the thing is, I literally thought about it and I was like, exactly, we need a complete masterclass for fundamentals. First of all, that see, AWS has like so many services. What services do we need to learn and what are all things? So I was like, let's create a dedicated and structured guide for all the data engineering enthusiasts that should learn AWS. Make sense? So in this particular masterclass, we're gonna learn so much, literally so much, and you cannot even imagine. And the best thing about this masterclass is you can be a beginner, total beginner, absolute beginner. I do not expect any kind of cloud knowledge as well because we are going to cover everything from scratch. And now people will say, do we need Python and SQL knowledge? I would say a little bit, a very little bit. Even if you do not have much, I would say it's fine because we are not covering Python SQL here. We are covering AWS, we are covering cloud, right? But if you have some knowledge, it will be better. Makes sense. So now let me just show you what exactly we are going to cover in this 6 hours long masterclass. And this is amazing, I know this. So the thing is, there are so many topics and because of space, I didn't mention all the topics, but yes, you will be covering all of these topics. As I just mentioned that we will be starting from very basics. So we'll first cover cloud computing, like what exactly is cloud computing, why you are learning cloud. You need to have this knowledge. You should not learn cloud because it is in demand. You should learn cloud because it is solving some problems, right? So what is cloud computing, then Iaas, Paas, Saas models, then AWS IAM, which is the, I would say, more new kind of stuff, and you should master this area, right, as a data engineer. Then virtualization, hypervisor, AWS EC2, AWS S3, AWS roles, AWS Python SDK, AWS Lambda triggers, CloudWatch, AWS Glue, AWS crawlers, AWS Athena, everything. And by the end of this video, you will first of all learn how to work with these tools and technologies. Second, you will know the why part as well. Then you will also gain strong hands-on because we are not just covering theory. We are covering everything practically. We will create each service. We will create each data engineering example within the masterclass. Make sense? So it is not like, hey, this is AWS EC2 and this is like this. No. Why part, theory part, practical part, implementation part, everything. Are you excited? Are you excited? Are you excited? And obviously you will learn everything with cool graphics and visuals, and you will learn everything from these notes. Let me just show you quickly. So here is our notes, and you will get all of these notes as well, and we gonna enjoy as well while learning all of these things. So you can just imagine how much you are going to learn in this particular masterclass. Can you imagine? Oh man, I am so excited to kickstart this particular masterclass. So this is our agenda, and I think this should be now clear that whether you should watch this video or you should watch this video, I would say. So now let's get started with the video. Let's get started with the masterclass. And before that, my favorite section of this video, I want to congratulate these people, these lovely data family members who have recently cracked their dream roles, dream offers. I have got so many other messages as well, so I will just add those messages in the next video. But for now, I was able to add only these messages or comments. So very congratulations to all of you who have cracked their dream offers, and they are like more recent messages, so I think they have already kickstarted their 2026 in the right way, right? So very congratulations to all of you, and we have some more people, so congratulations to all of you, 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 congratulations. So I'm really happy because these people make me feel proud. And if you are new on this channel, so now you can also become the part of this data family member, because we have fun, we learn together, we grow together. And if you just want to be the part of this journey, this community, you can just hit the subscribe button right now, and let's get started with our masterclass. And your name will be appearing here very soon, and these are my handles that you can just go and check out and just explore and just have fun. And let's get started. So now we are going to master AWS services for data engineering, and let me just get started with our cool heading: AWS fundamentals for data engineers. Why AWS fundamentals for data engineers? Why? Because AWS is such a wide tool, not a tool, I would say set of tools, a complete sphere of tools. And for data engineers, there are so many services, but not all. But the ones which are important, we will be mastering those services. Make sense? Simple. Okay, perfect. So we are all set to get started with this one. So if you have any idea about AWS before, it would be beneficial. If you do not have, don't worry, because that's why I'm creating this video. But I'm just telling you that even if you have some experience with AWS, this session will be like very insightful for you. Because see, when I was learning AWS, so I was just searching for like, is there any kind of specific, you can say, resource that I can use just for data engineering? Let's say I don't want to refer to other services, I just want to use the data, like services within the data engineering. I found some sources. I'm not saying that there are no sources available, but then I thought, let me connect all the dots which I feel that will be very beneficial for you, so that in just one video you will understand all of the things that are necessary for you. Simple. Okay. So now, as we just mentioned in the introduction as well, I am sticking to that particular point, that let's say if you are someone who doesn't have any kind of knowledge, right? No experience, and I would say you even haven't heard AWS before, but I think you would have heard AWS before, I'm so sure. So let's say no experience. Still, this video is for you, specifically for you, because we have designed this video in such a way. Simple, no experience, perfect. That is the best way to start any kind of video that is like that is covering everything from scratch, so that you would know. And by the way, all these cool visuals, these cool graphics that I'm just drawing throughout my video, okay, will be provided, and I think it's already uploaded, because obviously I am just creating all the notes for you, so you can enjoy all the notes as well, so you do not need to worry at all. Okay, so do not feel like, should I just draw meanwhile? You can draw, you can just take notes, it's a better approach. But if you are busy, if you don't have some like much time to do that, so do not worry at all, because you will get everything with this particular YouTube video. So let's get started with the AWS fundamentals for data engineers. The first topic that I want to cover is very important, and it is the fundamental and a base of every, you can say, cloud provider. And the question is very simple. What is, let me increase the text size. Perfect. What is cloud computing? And here I'm not talking about that definition which is available on internet, which is available on every, you can say, page, web page. I am talking about like actually what does it mean? Like what is actually the cloud computing? And you should know about this thing, because this is very important. This is the base of, I would say, your cloud journey. I know even if you are from, let's say, any other cloud platform, still you need to understand this concept in very much detail. So just tell me, what is cloud computing? Cloud computing is nothing but cloud computing. So let's say this is the user. Let's take an example of this user. We will just use this user for our video illustration. Okay, so let's say this is the user. So cloud computing, and I think this is a better color combination. So yeah, let's take it forward. So see, computing, cloud computing, this word is actually made up of two different words, cloud plus computing. Forget about cloud for now. Let's talk about computing. So let's say this computing. What is computing? First of all, if you do not know about computing, computing means basically the use of computers. Now you will say, Ansh Lamba, what is a computer? You use computer on a daily basis, right? You do not know the meaning of computer. See, computer. Computer means a machine which can compute something. That means which can process something, which can calculate something. Make sense? That is a concept of computing. Now let's say you have a machine like this. You call this machine as a computer. And when you use this machine, you call it as computing. Right? Computing means the use of computer. Why do you call this machine as computer? Because Ansh Lamba, it has so many things such as, I would say, storage, any kind of storage, right? Let's say any kind of storage that we can just attach. Do we have a hard disk? No? Okay. Do we have RAM? Okay, perfect. So we have everything inside this. That's why we do not have anything here. So we call this machine as a computer because it has all those components which are required to create a compute. First of all, RAM. Then ROM, that is like read-only memory, storage memory, right? Then processor and so many other things. Obviously, I'm not teaching you like what is a computer, but this is the basic fundamental thing, right? Because once you understand this, your base is ready. Then you can just go ahead with any cloud provider. So you have RAM, ROM, processor. Perfect. So this becomes the computer. And when you perform this thing, it becomes computing. Let's say you are using this thing. So you are computing, right? Perfect. So you do this task on a daily basis. If you are using laptop, computer on a daily basis, then you are just performing this task on a daily basis. Now, before cloud, this was the only concept. Okay, this was the only concept. Now cloud entered in the picture. Now what is a cloud, man? First of all, what is a cloud? If I need to just draw a cloud, let's say, okay, this is a cloud. Okay. Now let me just throw it in the background. Perfect. So now when I use everything, that means my whole machine, when moved to cloud, it becomes cloud computing. But what is a cloud? Cloud is nothing but a way, a connection, a bridge between you and your machine. What did I say? A kind of connection, let's say, between you and your machine. But Ansh Lamba, why do we need to create a connection between me and my machine? I can directly use a machine. Exactly. You use your machine directly, right? But let's say I am saying that your machine is not in front of you. Your machine is, let's say, in your friend's house, right? And you want to use that machine. So if you want to connect, if you want to use that machine while sitting in your place, sitting at your place, and your machine is let's say in your best friend's room, how will you do that? That is done through this cloud, this kind of connection. And how do we create this create that connection? With the help of internet. That is the concept of cloud computing. That's it. That means whenever you want to perform any kind of computing, but not physically, you do not have that machine in front of you, but with the help of internet, that becomes the concept of cloud computing, very high level concept of cloud computing. Why did I just discuss about this thing? Because if you have never heard about this concept, you need to first of all understand this thing before directly jumping on to, hey, what is a AWS? AWS is nothing but just a cloud provider. So now let's talk about what is AWS, because now we know what is cloud computing, right? Now you know what is cloud computing. Perfect. Now we can talk about what is AWS. Now comes your question. But this information was required. So now what is AWS? First of all, AWS stands for Amazon Web Services. And as you know, like Amazon has so many branches and so many domains. They have a kind of marketplace where they just allow sellers and buyers to come and communicate. They have Prime, where you just watch movies and waste your time, and you have Amazon Web Services, where they just sell the web services, right? So Amazon Web Services means, and by the way, AWS was the first cloud provider. Wow. And that's why AWS has the biggest market share right now. I think it's closer to 30%, I guess. You can just check. So AWS alone covers 30% of the entire cloud industry. So what AWS says, it says, bro, you want compute? Yes, I want to use computer. Okay. Let me do one thing. I have a lot of machines available. Okay. I have a lot of machines available. I will allow you to use my machines, and you can just make a connection using internet, and you can just pay me for that. That is your AWS. So that means this cloud connection, this cloud is actually AWS. So this machine is actually owned by AWS. You are simply using it. Make sense? So now is AWS is the only cloud provider we have available in the market? Not really. We have Azure. We have Azure. We have Azure. Let me just write it. Azure. We have AWS. Let me just write it here. And we have one more. Not one more. We have so many cloud providers, but these three are the major ones or bigger players. Big three. We do not have big four in cloud. We have big three. I can include IBM to call it as big four, but yeah, these are the four. So Azure and your GCP. Simple. Let's use blue color and this, let's say orange. So these two are the other cloud providers that you should know. Other cloud providers. Simple. Perfect. Cloud. Perfect. So now we know that we have some other cloud providers available as well. And now you'll say, Ansh, Lamba, what market share do these players have? I think Azure is 20%. I'm not sure about GCP. It should be around 10% as well. So yeah, but yeah, AWS is the biggest one because AWS has very early adoption. So that is the biggest advantage. And then obviously AWS has so many services. So yeah, it is what it is, plus reputation and plus brand and plus blah, blah, blah. So this is AWS. What now you have this answer, what is AWS? Amazon Web Services. Simple. Perfect. Now I want to talk about a very important concept. Now you will say, Ansh, Lamba, if we talk about, let's say, cloud computing, I know that I can just rent something. Okay. Now I can just use this machine and I can simply use it. But what is the advantage of it? Why can't I use my own machine? Why companies are just using cloud and they are not buying their machine? That should be a very legit question. And that I also had when I was learning cloud for the first time, because company has so much amount of money, right? They can buy their machines. Computers are not very expensive nowadays. And why they are just using cloud? Why cloud is growing instead of just going down? Because machines are becoming cheaper, right? Let me just tell you why. Because when you ask these questions, why, you become pro, and you need to ask these questions. Let me just tell you why cloud, because it's not just AWS. We cannot say why AWS. It's why cloud? Why do we need cloud? So the answer is very simple. Okay. The answer is, let's say there's a team of developers. Okay. Let's say there's a team of developers. Perfect. And this is a kind of, let's say, startup. Let's say they are building a startup. Okay. Now you know that obviously they would need computers. They would need some compute. Perfect. They would need some machines which can compute, right? So now they have two options. The option is either they can just buy these machines, and obviously you would know there will be so many machines. 1, 2, 3, 4, 5, so many, right? So many machines. Perfect. Makes sense. Now obviously they would need to buy so many machines. Okay. But tell me one thing. This is option 1. Okay. Cool. Option 1. Now, does that make any sense for a startup to buy these many machines during their initial phase? Does it make any sense? No, because this will require high cost, high investment. And I will just write so many highs right now. So just wait. So high cost, first of all. Now I know that I just need to use 5 machines. Let's say 5 machines. I know 5 machines are very less, but let's suppose 5 machines. Now I know that during let's say festival season, let's say this is a kind of startup for the marketplace, and I know that during, or let's say e-commerce business, so let's say during festival season, these machines will need to do much more tasks and would need to handle much more data with much more velocity because sales will be higher. So I would need to now increase the capacities of these machines. One thing, scaling, right? Scaling. Perfect. Scaling is the issue. Now, second thing, will I always use 5 machines? Sometimes, let's say in some months, I'm just using 2 machines. Okay. So I would say resources wastage, right? Then I would even need to add more machines, maybe, and immediately. I do not need any kind of downtime. I cannot afford any kind of downtime. I have to use a machine right away, like immediately. So one more thing is here, no downtime. And now, even if there's a downtime, because see, natural disasters can happen anywhere, right? So let's say there's a downtime. I need my data or basically machine to be replicated somewhere else so that I can immediately switch to that machine. Because see, customer doesn't care about anything. Just imagine yourself as well. If you're using any service, you just need to think about yourself. Bro, I just need to use the service. I do not care what happened to your data center, whatever happened to your example, ChatGPT. People started creating images like crazy. They didn't think about their data centers. That guy was crying, hey, our data centers are melting, our GPUs are melting. No one cared because they just wanted to create the picture so that they can just post it on social media. Customers do not actually look at the problem on the business side. So no downtime. We cannot afford any kind of downtime. Even if there's a downtime, we need data redundancy immediately. Plus, so many things, security, firewall rules, so many things, right? So now tell me one thing, will this startup company focus on these things or they will just focus on their business? So now cloud comes into the picture and cloud solves all of these problems. And I have just mentioned very few of the problems, very few. There are so many problems, bro, that cloud solves, but these are the high level problems that you can relate to, right? So now cloud says, let's use AWS. Let's say AWS says you can use my services and you do not need to worry about anything because I will handle everything for you. So now just tell me one thing. Which option, if you are the owner or basically you are developing that startup, which option will you pick? Just tell me, just to be honest. Obviously, no doubt, option 2, right? So that is why companies are using this thing. And plus the biggest advantage. Here, you do not need to buy all of these services. You simply rent. That means you are simply, let's say, using the services, using the machines, using everything. And you are simply paying the rent. That's it. Let's say you are living in a house. You do not own that house, but you simply give the rent. And you have the flexibility. You can anytime change the house. You can anytime discontinue their services, right? You can anytime ask for, let's say, like any other services as well. So that is the advantage of renting something. And specifically with the tech space, renting is like, I would say, the best thing. It was not the kind of concept before cloud because people used to worry a lot about their data, their privacy. But when actually AWS came into the market and they showed that, hey, you do not need to worry at all. It is the thing that we should manage. Infrastructure, those compute should not be the problem or basically the point of talk on the business side. We should manage that. Simple. And they tested it out in the market and it worked well. Then obviously Azure came into the picture, then GCP, then other cloud providers. So this race actually started after AWS. Makes sense? Like AWS actually created that hype of cloud. There was no hype before AWS. Let me just tell you. Even if there are cloud providers before AWS, AWS started the hype. Make sense? And here you simply buy everything. Now you have a clear answer. Why do you need to use cloud? Why companies, big companies are using cloud? Because it makes sense. Simple? Simple? Okay, perfect. Now, what cloud actually offers? Because Ansh, Lamba, we are data engineers. Why do we need to manage these machines? And if we do not need to manage these machines, why are companies asking us to know AWS, Azure, GCP? Why data engineering need to collaborate with cloud? That is another legit question. And let me just answer that as well. So for example, let's say, what cloud? Let's keep this heading. What cloud? So we only talked about these things, right? Machines, compute, RAM, storage, blah, blah, blah. Everything was revolving around these things like machines and all, right? But do you know what? Cloud, yes, started with these things as a core of their business. Machines, servers, that's it. That was the core, that's it. That was the initial point. But eventually, when they solved this problem, when they solved the problem of the machines, servers and everything, they started figuring out that, hey, machines are not the only problem. Even when anyone has the machines, they need to manage other areas as well within the machines. Very common example, let's say a database. If you want to manage or basically create a database, you first of all need to download the server. Perfect. Then you need to obviously do all of your stuff. But along with that, you need to take care of the scaling. You need to take care of the upgrades. You need to take care of everything on your own, right? So then they thought, is there any way we can also solve this problem? So they just started asking questions. Can we solve this? Can we solve this? Can we solve this? Because they have the major powerhouse, which is a computer, right? They have servers, they have computer. So that means anything that can be done on computer, they can handle that. Then eventually they started building the services. So initially it was just about servers or computers, not just servers. Okay. Now they have, I think, almost 200, oh my god, 200 plus services. Can you imagine? Like, this is just a one service. So that means there are 200 plus. So let's imagine there are 200 services. 199 more services are available in cloud. Can you imagine? Can you imagine? And let's say you are a data engineer. Let's say you are using 10 services. 10 services. Bro, 10 services are like, it's not a very small thing to know, right? So that's why data engineers need to know cloud, because you need to work with those services which are available in AWS as a data engineer. Make sense? So they have 200 plus services available. Make sense? For other tasks, or you can say other tasks or areas, basically, because they have like so many areas as well within the cloud. So this is the concept of cloud computing, why cloud, and what actually they are providing under the cloud. It's not just these servers, it's not just these machines. Yes, this was the initial point, but now they have so many other services. Makes sense. So now let's quickly talk about a very cool concept, which is not very, I would say, important, but if you know this concept, it will make you a better developer. Like, you should know about this thing. It is very simple. What is this thing? Cloud types. What do you mean cloud types? So we have just talked about that they have other tasks and other areas as well. and we have total 200 plus services. We have just talked about this thing, right? Perfect. So now for this particular, you can say, problem, they have categorized cloud into multiple areas. Okay. So first of all, just tell me one thing. If you have observed my point that I made just few minutes back, that if you want to create a server, database basically, right? So if you are a data person, you would have worked with databases any time, like let's say in the beginning days, initial days, or now you would have encountered with some use cases of database, right? So now if I say you want to manage a database, is that a complete question or is that a complete task? Not really. Follow-up questions can be, hey, is there any database existed now? If not, I would need to create a new database. That's the first question. Second, if we want to work with databases, we also need to ensure that our machine is able to handle the data, because all the data will be stored in the like disk, right? Because that is like on-premise database. Makes sense. So similarly, it's not just limited to databases. There are so many services which can be categorized into three major areas, and those three areas are called IaaS. You would have heard about this term, but now you will understand it. So we have IaaS, we have PaaS, and then we have one more thing, SaaS. Okay, IaaS, PaaS, SaaS. And this is like very simple. First of all, let's talk about IaaS. Okay, let's talk about this. So IaaS means infrastructure as a service. What does it mean? Full form is right, okay, infrastructure as a service, but what does it mean? So infrastructure as a service means cloud will just provide you the infrastructure. Okay, what is the best example of infrastructure? You know this because we have talked about this thing since the beginning. It is the server, the machine. What is infrastructure? Machine, right? Machine. This is the infrastructure. Okay, makes sense. Makes sense. Let me just make it back. This is the infrastructure where you are only and only using the infrastructure from cloud. You are not using anything else. So you will manage everything. Let's say all the things. Windows, if you're using Windows machine, Windows, upgrades, all the applications you want to install inside this machine, everything will be handled by you. AWS is just responsible to provide you this machine, obviously with the RAM that you have asked for, storage that you have asked for, but nothing inside that. You need to manage the machine. Same way, if you just go to any electronic shop. So if you go to any shop and you purchase any kind of machine, so you will simply get the empty machine, right? That's what I was just saying. Nowadays, I know that they just install some softwares and all, like Outlook and all, but you will simply get the machine. You are responsible for everything. They will not say, hey, you just need to install this application. No. So this is called infrastructure as a service, where AWS will just provide you the infrastructure and that's it. Okay, makes sense. Now, on the other hand, PaaS, platform as a service. This is one step ahead than this infrastructure. Cloud says, bro, I know that you cannot handle the infrastructure. I know you cannot handle the underlying scaling, upgrading. We will handle that. That means, let's say now you just want to manage a database. Let's say any database, PostgreSQL database or anything. Okay. So if you just want to use any kind of SQL database, let's say Postgre, PGSQL or pSQL, anything, right? So this can be managed by AWS. So that means you do not need to manage the machine on which this SQL database is installed. You just need to manage your application. You just need to manage your SQL database and that's it. Because they do not want you to manage anything else. Because they know you cannot manage, or you can manage, but you do not want to spend some time on that, on managing that. So this is called platform as a service. So they simply provide you the platform. You do not need to manage the infrastructure. You just need to manage the platform. Make sense? Make sense? So that means, let's say you are downloading any application, you just need to manage that. That's it. So currently, if you just want to, let's say, create a SQL database, you first of all need to manage your machine, because your machine should be working fine. Then you will install the SQL database. Then let's say you need to upgrade Windows, anything. You need to do that as well, right? You need to just do everything. But here, AWS says you do not need to manage anything. We will manage everything for you. And that's why these applications, SQL database, all those services, AWS Glue, storage services, all those things are platform as a service where you do not need to manage the infrastructure on which this SQL database is installed. Simple? Yeah. I could have taken some real life analogies as well, but do you know what? Being a data person, you can actually understand these concepts with respect to the original concept. Real life analogies will actually confuse you a little bit. So now the third thing is Saas, which is the most hyped thing right now, because everyone wants to just build Saas application. What is Saas? Saas means software as a service. This is even one step ahead. You do not even need to manage any kind of platform as well. What does it mean? So let's say you are using any kind of application, or let's say web application or anything. This is your Saas. This is your Saas, where you just use the end product. You just use the front end basically, where you do not need to download anything on your machine. You do not need to create something. You just need to use the services using the internet, and that's it. The final product. You do not need to manage any platform. You do not need to scale anything. Everything is like done by AWS. Everything. What is a good example of Saas? I would say Amazon itself is a Saas application, like the Amazon that you use to buy products. It's a Saas application. You're simply interacting with the web application, right? Or application, mobile application if you have. Second good example, if you're familiar with Fabric, Microsoft Fabric, it is also a Saas application where you do not need to manage any platform. You simply need to interact with the software that Microsoft has built. So all these are Saas. They're like countless definitions, or not definition, like examples for Saas applications. Simply go on Google, like any application is a Saas application. You are not managing their backend. You're not managing their infrastructure, nothing. You're simply using the final product. So this is the concept of Saas. Now you can just go on Google and learn the definitions if you want to learn. And let me just show you Iaas versus Paas versus Saas. Let's see. Do we have any kind of good documentation? So we have AWS one. Let's open this and you can simply read it. They are simply saying the same stuff, I'm so sure. So if I open anything, Iaas, yeah, see, Iaas contains the basic building blocks for cloud IT and typically provides access to networking features, computers. See, same thing. Then Paas. Paas is vendors remove the need for organization to manage the underlying infrastructure. The same thing that I have said. You do not need to manage the infrastructure, just the platform. Make sense? Then Saas. Saas vendors provide you with the software applications that are run and managed by the vendor. You just use their application that they have built. That's it. Make sense? You do not have to worry about how the service is maintained or how the underlying infrastructure is managed. You only need to think about how you will use that particular piece of software. Exactly. All those drag and drop things are actually Saas applications, right? Make sense? Okay, perfect. Now, this is very, very important. Like, you can say cloud, hybrid and on-premise. So let's talk about this thing as well. So what is this thing? So this is called, you can say, a kind of cloud models. Cloud models. So this is like cloud, hybrid and on-premise. Even if you just expand this, like just cloud, you will see, like not here, like you will see a complete breakdown of cloud as well. Like it's not again very, very important from the AWS lens, but let me still tell you just for your knowledge. So let's say if I say cloud types, or I would say cloud services types, that will be a better word for it, because what type of services do you use? Cloud services types. Perfect. Now I can show you cloud models, I would say. Cloud models or cloud architectures, that is a better word. So now, do you know what? Cloud has multiple architectures. And from the AWS point of view, I will just tell you that this is not directly related, but it is still fine to learn this. Cloud architecture means you can have 3 different architectures. For example, first of all, public cloud. This is for you, public cloud. Here we get everything, let's say all of those 3 kings, big 3. So these are like public cloud. So AWS, then we have Azure. All these are called public clouds. Why public clouds? Because you can access these cloud using your internet. These are not restricted ones, right? So these are the 3 major cloud providers, 3 kings, Azure, AWS, GCP. So these are called public clouds. Simple, perfect. Now we have one more thing, private. Now what is this private cloud? Now private cloud is not actually for you, like as an AWS user, because private clouds are like when you want to build a kind of cloud, same thing, but not for everyone. For let's say very specific customer. For example, the organizations which deal with the sensitive information. For example, government entities. For example, I would say all those, like you can imagine any example which will deal with any sensitive data today, in future, anytime. Simple. So you need to make sure that cloud, I'm not saying like cloud is not safe. Cloud is safe, but they need to be extra cautious because they cannot allow anyone to just use their services. So here private can be, let's say, any kind of building, anything. You can just imagine any kind of private thing which is like secured, like cloud but locked. Cloud but locked. Do we have any kind of lock here? Yeah, we can just use this. Let's say this one. Not this one because auth and IAM we have in public as well, but this is like private cloud, right? This cloud can be accessed by only that organization and that's it. You cannot access anything from that cloud. Make sense? Now the third one is very flexible. It's called hybrid. Hybrid means hybrid. So let's say you want to build a private cloud for sure, but also you want to use some public services. So when you create a kind of combo of both, then you just go with the hybrid approach. Let's say AWS plus private, some public things and plus some private thing. Let's say AWS is like very good at providing you some EC2 machines. You can just go with that. And other than that, you will just use your everything. So just a hypothetical situation. So you can just simply assume that, okay, that's how it works. Simple. It is not a like very big concept, but it is good to know things, right? So now I want to just tell you that, bro, your fundamentals are over. Okay, like obviously, like we need to just complete AWS fundamentals, but your cloud fundamentals are done. Now you are just very well versed, like what is cloud computing, AWS, why cloud, what cloud services types, cloud architecture. See, I could have directly taken you to the AWS demo to show you, hey, see, this is the application. See, now we can just do this. See, it is very easy to do that, but in order to explain you stuff so that you can understand why are you learning this thing, right? You're not learning because it is just written in the job description. You need to learn, yes, because you want to become a better developer. Yes, it is written in job description. Makes sense because you need to grab that job, but after grabbing that job, you need to perform the tasks as well, right? In order to sustain a good reputation in that organization. So for that purpose, you need to understand all of these things. Make sense? And I hope that you have a clear understanding for this. So now what are we trying to do? We are trying to now do a very important thing, which is the account creation of AWS, because now we want to do everything on AWS. So for that, we should have a cloud account. And the best thing is cloud account is free. What? Do they just provide services for free? Not like all the time, but if you are a new user, if you are a new learner, you can use AWS services for free for 6 months. Wow. Azure gives you free services for 30 days, but AWS gives you free services for 60, like not 60 days, sorry, 6 months. Okay. And not like infinite amount you can just spend, because you will say, oh, I can do whatever I want in 6 months. No, they just give you some amount, let's say $100, and you can just spend it in 6 months. And then you can just plan if you want to just use your services. You can upgrade your plan to pay as you go. Otherwise, you will simply use the default one, which is the free account, and that's it. Because some services are always free, so you can just keep using that free account. Some services are always free. Let's say IAM is always free. So let me just tell you how you can just create your own account. So simply open your favorite window, favorite browser, and you simply need to type AWS, and that's it. Search it. So here you will land on this particular web page, and here you can simply say create account. Simple. Oh, wow. So click on create account, and here you can simply say sign up for AWS. Then you will provide your root user email address, which will be used to create the root user. And as you can see, start with $100 in AWS credits, plus on up to $100 by completing various activities. So initially you will gain $100 in AWS credits. Then there are some activities that you can just perform within the AWS account. It can also increase your amount. I have recently created AWS account for my previous project that I have created on AWS, and then now this video. So earlier I got $100, and now the balance is like around $139. I was like, how? So then I got to know, okay, so they are just increasing my amount because I'm performing some activities, I'm building some stuff to explain, obviously, but yeah. So you can also do this, okay? Because it is just for learning and education. That's it. They just want you to learn their services, right? So you can quickly create your AWS account, okay? And you can simply create your AWS account name as well, which will be like a kind of username. And also it will ask you for the card details, so that you do not like create infinite accounts, because you will say I can create infinite email IDs, I will create infinite account. No, you should just provide the card details as well. So you can just create one account for you. Make sense? So then once you have everything, then you can just go back to this same page and click on sign on to console. And here you will be asked to perform these things. So initially you can be confused. You will be like, hey, I don't know my account ID. This is not your email ID. So obviously you do not have this thing, right? Then obviously you do not have the IAM username as well, because you have not created anything. So then you simply need to pick this particular option, sign in using root user email. Do not panic. Then you need to just provide the username, like any user email ID. Then after email ID, you can simply provide the password and click on sign in. And it will simply ask you for the multi-factor authentication. In my case, I have used my Microsoft Authenticator app. In your case, you can use any app. So simply provide the code here. So this is my AWS account. So in your case, it will be, I think by default white. You can just change the basically theme of this to dark. I like dark theme because it is good for developers, and you can also change it. See, I was just saying that I have credits remaining 139. Earlier it was like 100, but I was just creating so many services, so they just added more. So you can also, and I spent like $0.35, basically 35 cents this month, because I just created the new account for my previous video for YouTube and this one as well. So in your case, first of all, this is the UI, and let me just give you a quick overview, because UI is pretty much simple, nothing fancy, but still if you are new, you need that particular kind of, you can say, walkthrough in the portal, right? So first of all, on the top right corner, you will see your name that you would have decided for your account along with the account ID. So this is your account ID. You can just keep it safe. You can just note it down, because sometimes it can ask you, but I will just tell you everything, how you can just create the user, because that is the best thing to log in into your account. I have also created the user, but for now, I simply used my root user just to show you, because you do not have any kind of user now. So first of all, this is the home page, and here we have console home. Here you see the recently visited applications. I was just using these applications, so that is why it is coming here. Do not worry about that thing. Then we have applications. If we have any kind of application, it will pop up here. Then if you just scroll down, you will see cost and usage, and you will see how many days are remaining for your, you can say, free tier tenure. So this is like 163 days left, and after that I can just upgrade it, or it's my choice, like literally. So now you can explore more, and you can say total credits on, okay, 40 of, oh, so I earned like $40 of credit. Okay, makes sense, because I launched an EC2 instead. Okay, so you will earn this as well, because obviously you'll be just creating so many services. Create a web app using AWS Lambda. Okay, makes sense, makes sense. So there are some things that you can explore for AWS, because see, why are they just doing this thing? So that you will learn more and more things, right? And obviously when you learn more and more things, you can just spend some amount to explore their services for the educational purpose, and that makes sense. Okay, if I scroll down, you will see some more stuff as well. To be honest, all of this stuff is not very much relevant to you, because you will be spending most of your time in this upper area as such. Simple. So first of all, if I click on these three lines, which is also called as menu, you will have two options: my application and all services. Let me just click on all services, and here you will see all of the services provided by AWS. Remember, I told you 200 plus services. Wow. And now we were only talking about, hey, we can just use compute services. So yes, compute services are here. But other than that, we have container services, storage services, database services, migration, network, like so many. Machine learning as well. And they have like a big list of machine learning services. And you know what? Before LLM and before AI, like not before AI, because machine learning is a part of AI. Before these LLM era, AWS machine learning was very popular, because they were able to just build your machine learning models like this, like this. Then they have end user computing, IoT, game development, everything. Simple. Even the blockchain. Okay, so these are the services that we have within the AWS. Now, being a data engineer, you do not need to cover all of these services just to give you some relaxation. We do not need to master all of the services. We just cover only those services which are relevant for the data engineering. Simple. So this is the UI. You can also click on this basically button, and here you will see the similar thing there, where they have just created the categories for each kind of services, right? Like front end, management, and some other things as well. Perfect. Then the best thing is, let me just click on this button to go to home page. The best thing is, let's say I want to use a service. So I do not go here. Then I simply use this search button, the search bar, to simply need to use this. So let's say I want to use EC2. Okay, what is EC2? I do not worry at all. Let's say I want to use EC2. Okay, EC2. I will simply search it and I will see the service. That's how you search for the services within AWS. Any service. So Ansh, what if we do not remember the name? Do not worry. If you are very new, then yes, you can say that you will not remember the name. If you will use AWS for, let's say, 2 to 3 times, you will remember the name. EC2, S3, Athena, Glue, Crawler. Ansh, what happened? We don't know anything. Don't worry. I'm just telling you that you will remember these names. And whenever you are just like, whenever you, let's say you do not remember any name, go to Google, search for it, and you will get the name. So it's not a big deal, right? It's very simple. So this is your UI, I would say. Nothing fancy, nothing special. And yes, there are so many things that we'll be exploring like along with this video. You do not need to cover everything in the beginning of the video. No, you grow step by step. You learn step by step. Okay, so this was a UI walkthrough for AWS console, first of all, right? So now we need to talk about a very important concept, not from the development perspective, but from the company or basically business perspective, or you can say as an owner perspective. What do I mean? So when you are a developer in AWS, right? Data engineer, software engineer, anyone, but yes, we are data engineers. So let's say you are a data engineer. You need to worry about the solutions that you build in AWS, all the solutions. You build, let's say, pipelines, you build databases, you build data warehouses, you automate everything, you build functions, everything. But you do not worry about data redundancy, right? Why? Because AWS takes care of it. AWS takes care of everything. Data redundancy, like how it needs to take a backup of your data. You do not worry at all. Why? Because AWS is doing that work. So it is not very important from the development perspective. But obviously, when you know these things, you become a better developer because you know how things are behaving. Plus, when you become the senior data engineer, you need to take these decisions as well. Yes, you need to take this architecture level decisions as well. You will say, okay, let's build this solution and we will just keep this data for, let's say, glacier mode, because we don't need to use this data for, let's say, like frequently, and we will just keep this data in the hot mode. So you need to take these decisions, right? When you become the senior data engineer. So what do you think? You just need to be the junior level data engineer? Not really, right? You need to behave like a senior data engineer. And let me be honest with you, after AI and LLM stuff, no one is a senior data engineer or a junior data engineer. It's just like a data engineer, because they do not worry at all if you have 10 years of experience, if you have 1 year of experience. If you have the skills, if you have the knowledge, if you can perform those stuff, obviously you can just do the work. Yes, when you have some experience, let's say 10 years, 15 years, they will just tend to trust you more. But that's not the case now. The industry is shifting now. Why? Because the person with 15 years of experience, yes, the person has that wisdom, person has that particular, you can say, decision taking power. But what about the skills? Data engineering industry, I would say, is totally changed within the last 3 years. Considering Lakehouse, those Delta Lake, Spark 4.0, 4.1, all of those things literally changed everything. So if someone with, let's say, 10 years experience, 15 plus years of experience, if the person is not upgraded with those particular trends, how the person can take the decision? Because person is not having the right knowledge, person is not having the right upgrades, updates, anything. Who have that like updated knowledge? You. I do not know if you have 10 years of experience, or if you have 1 year experience. If you have the knowledge, you are capable to take that decisions. Or even if you are not taking that decision, you can provide the knowledge to someone who can take the decision. So obviously your importance will become more. Got my point? Ansh Lamba is giving some philosophical lectures. Bro, it is for your growth. So it's up to you if you just want to take this advice. Okay. So now let's quickly cover that particular concept. It's called data redundancy. And by the way, if you are just sitting in the interviews, obviously these questions will be there. So yeah. So let's talk about the data redundancy and basically the regions and the availability zones within AWS. Okay. So as you would already know that this is our, you can say, home page. If you observe it carefully, can you see this thing? Select region. Can you see this thing? Because the next topic that we are trying to uncover is strongly relying on this particular thing. If I just click on this drop down, let me just do it. I will see CA Central 1, that means Canada Central 1, supported regions, that means these are supported regions, right? If I click on this drop down, I will see that I have so many regions available, right? Exactly. Now we are just trying to cover this part, which is regions and availability zones. So I first wanted to show you like where it actually resides within the AWS account console. So now let's discuss what is this thing and why is this thing. Like I love like why questions more than what, because you should always cover why and then what. So let's try to discuss regions and zones. The full name is availability zones, but let's say zones. So first of all, what is a region? If I just talk about, hey, what is a region? So what happens is each region. So let's say we have this region and we have this region. Make sense? Simple. Now what is a region? Region is basically, you can assume that a part, a specific area in the world. It can be Mumbai. It can be, let's say, Bangalore. It can be Dubai. Like any specific area. Region means like simple English word, region. Any specific region within the globe. Make sense? So what is like so significant in the cloud, you can say, learning? So basically what happens, let's say you want to create your resources, and just for the simplicity, let's say you want to create your virtual machine. We will talk about virtual machines in detail. So let's say you just want to create a server, right? You just want to, let's say, use any resource from the cloud. So what you can do, you will pick the resource that you want to just use or basically create. Then what you will do, you will also pick the region, because AWS will ask, hey, where you want to deploy those particular resources. Okay, so let's say you are this user. Where is that user? Okay, so let's say you are this user. Make sense? So this user has now choice. Yes, cloud provides us a lot of choices. So let's say this is the user. So the person needs to deploy, let's say, any VM, any server. Let's say this is the server, right? So now obviously this resource will be deployed on the AWS account, right? So the person can just use this resource, but now the person has choice whether this resource should be deployed to this region or this region. For example, just for the example, let's say this is Bangalore. Wow. This is Bangalore. Okay. And this is, let's say, Dubai. Make sense? Or let's say Canada Central, because it can be specific to the state, it can be specific to the area. It differs from country to country. Some countries prefer directions, let's say Canada Central, Canada East, US East, right? Some say like Asia Pacific East, those things. But obviously we know that there will be a city, there will be an area, specific area, right? So let's say you have the choice. This is the region 1 and this is the region 2. Perfect. Simple. Let's change the color for simplicity. Perfect. So now you have the choice that you can just make. Now the thing is, now you will say how we can just decide. How we can decide. So the ideal situation is you should always deploy your resources closer to your location so that you can easily access those resources. The delay will be less, and there are like so many obviously parameters, but this is the very basic, you can say, formula that you can use. If you are closer to Bangalore, pick Bangalore. If you're closer to Dubai, pick Dubai. If you're closer to US, pick US. If you're closer to Canada, pick Canada. This is the very basic formula. I know there are like so many parameters involved, and even if let's say you pick US East and if you live in India, that doesn't mean that you cannot use the resources. It is not like that. It is just like you will experience much more, you can say, faster transactions, egress cost will be less, and all those parameters actually do matter. But ideally we try to deploy our resources closer to our location. Simple? Yes. And the best thing about these regions is each region is isolated. That means this specific region, this one, has nothing to do with this region. This is isolated. Make sense? So that means this region has its own availability zones that we are just trying to talk after this. This region has everything on their own. They do not need to rely on any other region. Simple. So let me now show you the AWS account. So if I just click here, I will see so many regions, right? In the US, I have 1, 2, 3, 4 regions. US East 1, US East 2, US West 1, West 2. Then Asia Pacific. Then I have all these, see, Mumbai, Singapore, Sydney, Tokyo, and then Canada Central. In Canada, I just have one because I'm just using the free, you can say, account. There are 70 regions that are not enabled for this account. Obviously, they have not enabled all the regions. In Europe, we have so many regions. In South America, we just have one. So that's how you just decide the regions. Make sense? Simple. So now let's talk about the zone. So this was all about region. So now what happens within each region? It's not like you only get one location to store your resources. No. Remember we talked about that cloud, make sure our data security, make sure about the data redundancy as well, taking the backups, everything, right? Let's say one machine is not working, so the other machine should be immediately connected to our solution. So how all those things work? This works under the region. So let's pick any one region. Let's say I want to pick this Bangalore region. Okay. So what happens within the each region? So this is our Bangalore region. Let's say region 1. So within each region, we have something called as zones, availability zones. Okay. So what will happen? Let's say this is the zone number 1 and this is the zone number 2 and this is the zone number 3. Let's say. Okay. Let's say. So this is zone number 1. This is zone 2. And this is all happening within the one region, zone 3. So now why do we need zones? So what happens? And before like discussing about zones, multiple zones, what each zone represents? Each zone represents, there is a data center within each zone. For example, in the region, which is Mumbai, right? Mumbai is considered as a region. Now within Mumbai, there can be data centers at multiple locations. Let's say Canada Central. Canada Central means, I think, Montreal, right? So around that area, there can be multiple data centers. Now what is a data center? Data center means where your actual data, resources, all the services reside. Okay. And when we create a zone, when we just create a boundary around that data center, it becomes a zone. So that means this is a zone, but actually within this we have a data center. So we can just let's say imagine that this is our data center. Let's say this one. Perfect. So this is our data center. Make sense? This is our data center. Perfect. So now this data center is isolated as well. Oh really? Yes. Why? Because let's say you have your server here in the zone 1. Okay. Now unfortunately this data center, this zone is down due to, let's say, power outage, and you have already seen like you do not receive electricity in some areas during, let's say, summer. Like it can be any reason, right? So let's say this data center is down, this zone is down, the entire zone, the entire, you can say, area is down, right? So now at that time, how will you access your machine? There's no there's no resource available, right, in that zone, because the whole zone is down. Whole zone, entire zone is down. Then comes the role of zone 2. The zone 2 will say, okay, you are down, don't worry, I will just provide my resources. So what happens in reality, whenever you say, hey, create my resource, AWS will not just create one resource in that region. No, it will actually create 3 resources for you. Wow, it's called redundancy. So one machine will reside here, one machine will reside here, and one machine will reside here. That's the concept of zones. So now you can access this region, right? This region, because you're just connecting to region, but under the hood there are multiple zones. So by default you will connect to zone 1. If due to any reason this zone is not available, this whole zone is down, then zone 2. If this zone 2 is also down, then zone 3. Now I know you ultra legendary people will say, hey bro, what if the entire region is down? Like it's a very big thing, by the way, but it can happen. It's nature, right? It can happen. So in that particular scenario, you can still access your data even if the entire region is down. That's called multi-region redundancy. So this is the concept. So obviously it is not like by default behavior, you need to enable it. So what you can say, hey, deploy my resources across multiple regions as well. So let's say you want to deploy one resource in region Bangalore, and second region is, let's say, Canada Central. Make sense? So if one region is down, you can access the second region. So this is the concept of regions and availability zones, and I hope it makes sense. Okay, and now let me just show you the official documentation so that you can also quickly cover some things which are important for you, and we will simply quickly go through it because there are so many things, but now you are able to understand everything, I'm so sure. Regions and availability zones. Okay, this is AWS. Okay, regions and zones. Let me expand it. Perfect. So there's a PDF you can download as well. But see, each region is designed to isolate from other regions. That's exactly what we discussed. And these are the availability zones. And this is a nice diagram. Let me see. So see, they have actually showed the same thing. So region, single region, and within the one region we have availability zone 1, availability zone 2, availability zone 3. Make sense? And then you can also say local zones. Now what is a local zone? Local zone is basically the extension of AWS region. This basically means, let's say you have a region, like you have deployed your resources in the region, and region is, let's say, US West 2. But you know, within that US West 2, we have greater population in a specific area, let's say Las Vegas. So they will simply create an extension of that region, and it's called local zone. So what is the advantage of it? I think Los Angeles, yeah, LA, same thing. So I always confuse between Las Vegas and LA. So the code for local zone is its region code followed by an identifier that indicates its physical location. So that means, yes, we want to deploy our resource in the US West 2, but within that US West 2, US West 2 is like so big. We want our resource in LA. Why? Because LA is more populated. Users are more. We need, you can say, minimum latency time, single digit latency time in like you can say accessing the applications. So that's the whole idea of local zones. It is like, I would say, specific to AWS only, because I haven't seen something similar to this thing in Azure, because in Azure we have like fine grained availability zone. We can pick any specific availability zone, but I think they have just created like local zones. I think this is also a good idea. So I'm just simply telling you what is this thing. Make sense? So this is the entire concept of regions and availability zone, and this local zone as well. This is not something different, but you can say we are deploying our resources, and we are also saying, hey, just deploy the resources closer to this area, because our office, or let's say our users, are more in this specific city or this specific area. Simple. Make sense? And you can even learn more about AWS local zones if you want to. So they are also saying the same thing. Run low latency. Why we need to use local zones? Simplified hybrid cloud migrations, meet stringent data residency requirements. AWS local zones places compute storage database close to large population and industry centers. Make sense? Simple. So okay, so now we understand both the things, which is, one thing is this, and second thing is this one, regions and zones as well. Perfect. Now let's talk about the, I would say, new feature. Not new, but yeah, it was added like after so long. Like if I compare the traditional services of AWS, it was added after so many services. It's called IAM, and in today's era this has become like the non-negotiable, because, and especially for data engineers, you have to know IAM, because data engineers are the ones who work with so many services. They just integrate so many services to create pipelines, so they have to understand this IAM. So first of all, let me just show you IAM so that you can just feel it before learning it. So if you just go to your AWS console, just go to your search bar and simply search IAM. See, IAM, manage access to AWS resources. Simply click on this resource, and then you will land on this particular dashboard. Yes, your dashboard will look a little bit different in terms of these user groups, users, roles, because I have some things, I was just testing so many things. So now your this area will be 00000, but it's fine. Okay. So first of all, why IAM? If you have clicked on IAM option, you would have read one line, managing the access, and here also we can see identity and access management. That is the full form of IAM, identity and the access management. So just tell me one thing. We know that cloud is very secure, right? Cloud is like very secure. So let's say you are the user, right? You are the user, and this user needs to let's say access something. Let's take the real example, because I know you want to access something. Let's say you want to log in into your account, anything, it can be anything, right? Let's say you want to access any streaming platform, anything, let's say Prime. So what you will do, you will log in with your credentials, right? Simple, because you need to show that you have purchased the membership, then only you can just watch the movies. Make sense? You have to do it, right? Perfect. So this is the common thing. So now just tell me one thing, that if you want to access the AWS services, what do? You log in, you just provide your credentials, and you just tell AWS head that, hey, I have the access, right? Now just tell me one thing. Here you would need to, like, you are the root user, you are the owner of your account. Now in your team, let's say you are a team lead, let's say you are a senior data engineer, or let's say you are just a data engineer, but you have like some other team members as well. Now in the entire organization, we have created so many services. We have created services for development team, like web development team. We have created services for machine learning team. We have created services for data engineering team. So just tell me one thing. Do I need to provide access to all of those services to all the users, or do I need to restrict it? The answer is I need to restrict it, right? Make sense? Simple. So that's how we manage all of these things in AWS using IAM. That means identity and access management. Okay. Identity and access management. Simple. So now what will happen? There are some concepts in this. They're like basically 4 to 5 concepts that you need to understand step by step. So first concept is very, very simple. It is called user. So first thing first, let's say you are the owner of your organization, or let's say you are the senior in your organization. Now there will be like some new joinings as well, right? So let's say there are so many users. There are so many users joining your team, right? Or let's say joining the organization. Makes sense. And now we have AWS Cloud, as we know that, let's say this is our AWS Cloud, where we have created all the services, and now you know the fundamental things as well. So you have this cloud. So now these users who are literally new, like they do not know how to access AWS, and they cannot even access your AWS, right? Because you have not provided the access. So first of all, the very first step in the IAM journey is adding these users into the AWS cloud. You need to first of all register them as user. Only then these people can access your AWS account, right? See, you have created the AWS account. Simple. So that means you can use the AWS services. Simple. Now within that you have some users who are joining your team, so that they can develop something, they can do their work. So in order to do that, you first need to create the user. So that is the very first step in that particular journey. Okay, simple. And now let me show you how you can also create the users. So first of all, let me just open my lovely IAM dashboard, and you should already know how we just accessed it. So just go to your home page, search IAM and click here, and that's it. So this is the dashboard. So now here, if I click on users, first of all, let's discuss about users, then you will just discuss user groups and then roles and then policies one by one thing at a time. Click on users, and here you will see that I have these 2 users. Okay. In your case, it will be empty, I know, but in my case, I can see 2 users because I have already created 2 users because I was just testing something. Make sense? So now let's quickly create a new user. Click here, create user, and click here. So now what you will do, let's say there is a new joinee whose name is, let's say, what name we should pick? Let me just ask ChatGPT. Give me, because if I just take random name, they will say, hey, you didn't take my name, just use my name. Give me a random name. Let's say, bro, are these names? What is this? Give me human or human friendly name. Easy names. Let's say Max, Leo, no, Anna. Let's say Anna. Okay. Let's say Anna is joining our team. So welcome, Anna. So now what we will do, we will create the user account for her or him. I don't know, Anna is she or he. So let's say Anna. So what I will do, I'll simply say username Anna, right? And obviously I need to provide access to console so that Anna can access this AWS console. I will check this box and then I can just provide the password. I can say auto-generated password. So at that time, Anna would need to reset the password. Let's say I'm just providing password as well. Okay. So I can simply say any password, very simple one. Okay, and then let me just add more characters. Yeah, perfect. So let me just click on next. Perfect. So now the console is saying, do you want to add Anna to these groups? I already have some groups, but you do not need to worry about that. You will see nothing here. Okay, I don't want to add user any group. I will simply say next, because I don't want to add anything now. And now review and create. Yes, create. So now you will see that you have created this you can say user. If I go now on the users tab by here, and you haven't reviewed, yeah, I don't need to review. So now you can see Anna is here. That means we have created one user who is Anna. Now this Anna, if I click here, this user, this is the information for that particular user. Now this user can access this AWS console with the credentials, and let me just show you how. If I just open a new tab, let's say I open a new tab, and if I say AWS console, and if I go to sign into console, oh man, so let me first of all log out because it will keep on asking me. Or I can open Edge. Let me just open Edge. So AWS console, perfect. So I'm opening Edge, sign into console. So here, so currently we need to sign in using this UI. We cannot say root user because Anna is not the root user. Root user is me. So now it is asking for the account ID. So now obviously you have not set up the alias. That is not very necessary thing, but in order to get the account ID, you can simply go to the AWS console, and this is your account ID that you can see, right? You can just copy it, but I know my alias as well, but you can just copy these 12-digit numbers and you can just type it there, simple. Okay, so let me just type my alias quickly. So I'm using my alias because I like it. In the username, I can simply use Anna because that is the username, and password, the same password that I put it, and then I can simply say sign in. So now what will happen? Okay, so now it is asking us to reset the password, that it always does because it's a good practice. So I have put the password. Now let me just click on confirm password change. Perfect. So continue to sign in, and now you will see that Anna has logged in to this AWS console, which is my, see, account ID is same. But you know what? Anna doesn't have any kind of access. That's why you are seeing, what do you want, bro? That's why you are seeing this access denied, because we have not provided any access now, but we have simply added the user into our system. That's how you can create the users. Simple. And yes, you can even create a user for yourself as well. And I have also created for me. That's why if I click here, you will also see in the users tab, I have created for me, Ansh Lamba. That's what I use to log in, and it's a good practice. Instead of just using email ID, root user again and again, you can use your IAM user, and it's a good practice. But make sure whenever you create this user, let me just actually show you. If I go to Anna, so currently Anna cannot access anything, right? Because we have not provided any kind of policy, basically permission, right? So let me now just talk about policy, and then you just provide the policies as well. Simple. Okay, let's learn one by one. So now if I open my whiteboard, so now let's talk about the policies. Now what are policies? Policy, I would say, is a fancy name for just, you can say, permissions. I would say policy slash permission, because you can understand better when you will see permission. Policy slash permission. Simple. So now just tell me one thing. These users, let's say Anna, let's say this Anna is added in our AWS account. Simple. Yes, but this Anna doesn't have any kind of access. No access. Anna can only access our AWS console, and that's it. And obviously in the real world, we need to just provide the access, right? So what we do, we say, Anna, you have a permission. Let's say you are a senior engineer, senior developer. Let me just provide you a full access to my resources. And in short, let's provide the admin access to this person because I trust Anna. Not in real life, but yeah. So admin access. I want to provide the admin access. Simple. Okay. Makes sense. Makes sense. Admin access. Simple. So Anna has the admin access. Wow. So now this admin access will be used whenever Anna will be logging into the AWS console. Make sense? So now what will happen? Now Anna can access almost all the things that an admin can do. Now a very good question can be asked, who will define the rules for admin access? Because admin access is just a word, admin access. What are the rules listed in the policy, in that policy? That's a very good question. So what happens? There are pre-built rules for each policy, which makes our life easy because we do not need to define, you can say, policies from scratch every time. Because I know if I want to provide admin access, I need to provide access to all the resources, full access. Simple. AWS already knows this. So AWS created the policy for it. But that doesn't mean that you cannot build your custom policies. You can build custom policies, but most of the time you will not create custom policies because we have a huge list of policies available. But still, if you are someone who just want to be very, very specific that I just want to provide this access and not that access, you can just do that. And I will just show you that as well. There are pre-built rules for each policy, but you can also make a custom policy. Simple, as per the requirements. Simple. So now let me show you how you can provide the access like that particular policy. So I will simply go to Anna. Okay. So currently, if you go to permission policies, why I am seeing this this policy? I didn't provide this policy. So it is a by default policy that every user gets, so that person can use actually the password, right? User change password, because whatever password I create here will go to the user as well. Perfect. So now if I want to assign more permissions, right, you can click on this button, which is add permissions. See, click here and then you can say add permissions. Now there are so many things: add user, copy permissions. No, you simply need to click on attach policies directly. Click here and you will see a long list. Can you imagine? 1442 policies are already created for us, very fine grained, to make our life easy. Because see, administrative tasks are not easy in cloud platforms, not at all. So it makes our life easy because we know that we can easily do this, we can easily do that. So it is really good. Make sense? So we were talking that we want to provide admin access, right? See, administrator access. If I click on this plus button, you will see the rules. So this is a rule. Wow. This is the rule written. And what is the rule? Rule is saying you want to provide allow permission, that means allow an action on all the services and all the resources. All the actions. You can say contributor, developer, reader, writer, everything. And resource means all the resources, like all of the AWS resources. So this is the most privileged, you can say, access that we can just provide to someone. Administrative access or administrator access. Make sense? So let me just check this box and I will simply say next and add permissions. Simple. Now if I go to Anna account, if I simply refresh this thing, you will see I can literally see everything. See, everything is there that I was seeing with my own account as well. There are some things like current month. These are like obviously restricted to just root user, but I can see everything: credits remaining, days remaining, all the services, everything. I can literally create any service as well using this account, this Anna account. That's how you create the user. You attach a policy, right? Perfect. Simple. It was easy. Now let's quickly talk about the groups, because we are just looking at those user groups again and again. Let's talk about it. So we have Anna sorted. Perfect. Now let's talk about the user groups. And in the real life, we use user groups 99% of the time instead of independent users, and you will know how and why. So let's say we have Anna, right? We hired Anna and we are very happy with Anna, but now our business is growing and now we need to hire more people. So now let's say by default there was just one person, Anna, but now we have users, so many users, right? So we are growing our team and wow, see, and let's actually divide it. So let's say some people are here, some people are here. Perfect. So now what happens after Anna joined, our business grew exponentially, and now we have so many other developers joining our team as well. So now just tell me one thing, who will do the same repetitive tasks again and again for all the users? First of all, one task is repetitive. Let me just write it for you. Yes, we need to add each user to AWS manually. That is non-negotiable, because we have to, like, we can obviously write some scripts, but I'm just telling you that you need to do it. You need to do it manually, either through UI, through REST API, through script, anything, but you are responsible to do that. Okay, makes sense? Got the intention? Okay, very good. Now this is done, like step number one is done, like we have added the user. So let's say these users are added to our AWS console, but now what about policies? What about policies? Here comes the role of, or let's say here comes, because you will be confused with role, this role and above role. Here comes the user groups into the picture. So what I can do, because that's not the just like only problem that we have. You will say, okay, we can add these users manually and we can just attach the policies as well, not a big deal. But let's say this group is the analytics group, data analytics group. Okay, data analytics, or let's say just analytics. These are the analytics team developer. Make sense? And this group is, let's say, data science team. Data science team, or let's say, yeah, data science team. Perfect. So these two groups are different. Now just tell me one thing. Will I provide the same permissions to both the groups? Obviously not. Obviously not, right? Obviously not. So now what we can do, we can create groups. Wow. Yes. We can say analytics group. Okay. We can say data science group. Okay. So now what we can do, remember we basically provided the permission to Anna. So now instead of providing the permission to Anna, I can create a new group and I can provide the permission to the whole group. So now what will happen? Any group. So let's say I am the owner. So let's say Anna is the admin. Okay. Or let's just write admin, because I am the admin, not Anna, because let's say admin. So what I will do, I will simply pick these groups, analytics group, and so I will simply say analytics group, perfect. And I have one more group. I have data science group as well. So what I will do, let's say DS group. Oh, DS group. So what I will do, I will list all the permissions. Let's say I want S3 permission. What is S3? You do not need to know. I need Athena permission and blah, blah, blah. Some permissions, right? And here I need S3 permission. I need SageMaker permission and blah, 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 blah. Okay. So all the rules are different, but I will just define once. I will just define once. I will simply create these groups and I will just provide all of the permissions to these groups once. And then what I will do, if you want to join these analytics group, this group, like let's say these people want to join this group, I will simply add these people into my group. Perfect. Simple. I do not need to do anything like independently. I can simply add these people into this group and that's it. And similarly with data science as well. Perfect. That's how user groups work. Make sense? Perfect. So that is the concept of user groups. I do not need to add I do not need to provide policy to individual person. So now let me just show you how you can just do that. So here we are in the IAM, and bro, IAM is the only thing which are more aligned towards data engineers. Why? Because data engineers are the upstream for analytics team, data science team. So they actually manage all of the permissions, all of those things. Now in some bigger organizations, yes, there can be some people where they'll be like dedicated cloud admins, but with the rise in AI, companies do not hire just a role called cloud admin. No, senior data engineers will eventually handle all of these permissions things, and because it is just a like 1 minute task, because you just need to create a group and add more and more new people and that's it. So senior data engineers handle those things. Simple. Perfect. So let me just show you. If you just go to groups, user groups, I have 2 groups. Let me just create a new one for you. So I will simply type a user group name. I will simply say, let's say analytics group. Analytics group. Simple. And here it is saying that do you want to add any user? For now, no. We just want to create an empty group. We are just starting our groups. So I will say, and it is saying like which permission you want to attach. Let's say I want to attach only S3 permission. Simply search S3 full access. Don't worry, we can add more and more permissions later on as well, but initially we just want to provide S3 full access. Simple. Create user group and that's it. So here we have analytics group. If you open this, we can now add users directly into this group. What will happen? Like whoever I will add in this group, simple, the person will automatically get all the permissions that are defined in this group, and you can just double check what are the permissions defined in this group by going on this tab, permissions. So currently we just have 1 permission. We can add more permission and that's how you just perform user groups and everything. Simple. Was it simple? I think so. Like it is very simple. It is very simple. Now the last thing in IAM, which is, see, IAM is newly added. So it is the hot topic, and I would say one of the hottest topics in the interviews as well. So you have to master it. Then the second, like the last thing is roles. This is very interesting. This is very interesting. Now what are roles? What are roles? Any guesses? Any guesses? So let's say currently we are only talking about how a person can access the services, how a specific person can access the services. But what about the services? Like how services can communicate to each other. For example, I know that we haven't talked about any service in detail. Like obviously we're talking about IAM and all. We haven't talked about those storage services or data processing services. So let's say I want to create a service called Athena, or let's say Glue, AWS Glue. So this is my AWS Glue. Simple. This is my AWS Glue, and this Glue wants to talk to S3. Okay. This Glue wants to talk to S3. Why? What why? Obviously you will create the pipelines and you will just move the data from one place to another. So in order to read the data and write the data, you would need some permissions. And this S3 is not like very easy to access because it is secured. And this is the storage solution in AWS. That is like our very next topic to cover this. So it is very secure. You cannot directly talk to it like this. So now whenever AWS Glue will go to AWS S3 to talk. So AWS S3 will say, bro, who are you? Who are you? Do you have any permission to touch or basically to access me? Do you have any kind of permission? So AWS will say no. So this Glue will say no. So S3 will say, bro, just rotate this arrow in the U-turn. In the U-turn, because you are not allowed to access me without any kind of permission. So it will try to access it, but it will take the U-turn. No role. Or let's say no role defined. Make sense? But when we have the role defined, what kind of role? That's a very good question. The role will say AWS Glue can access S3. Oh, okay. Can we define this? Yes. I will say AWS Glue can access S3. Okay. Which glue? Because there can be like so many instances of glue. Any glue. Any glue can access S3. This is a role. This is a role. Any glue can access any S3. Okay. Let's define this. I will say any glue can access any S3. This is the role. Okay, makes sense. This is the role. Okay, simple. Now this role, let me just take it out. This is the role. So this role will be assigned. Let's say this is the role. This role will be assigned to my glue, because there can be any glue, right? Like in the organization, there can be like hundreds of glues instances. So we need to assign my glue that role. So I will simply assign this role here like this. So let's say this is the role. Let me just drop this arrow. So this is the role. Perfect. I'm doing all of this just for your notes. Can you imagine? So role, any glue can access any S3. This is a role. I assigned it to my instance. Assigned to my glue instance. To, let's say, my glue instance. Make sense? Instance means any object that we are creating, correct? So I created this role and I assigned it to my instance. Now what will happen? I will access this, basically not I, basically glue will access to this S3, and now it can access. Now it can access. Why? Because this role is assigned to this glue. This works. This works perfect. And this is allowed. Simple. Simple. This is allowed. That's how we just perform roles. And let me just show you now. This is very interesting. And this is the, you can say 90% of the time you will be managing all of the roles, because data engineers know how to create roles and what roles are required. Because see, data engineers travel data from one place to another and read data, write data. So we know how to talk to different technologies. And why do we need to talk to different technologies? The downstream people, downstream doesn't mean like down. Downstream means like it is a flow, upstream, downstream. So downstream people, analytics people, data science people, they just use one or two technologies and that's it. They do not connect like multiple technologies together. Make sense? They will hardly connect S3 to their something, and that role will be defined by you as well. So you need to master this, not them. So let me just open my AWS. So here I will simply go to roles. So yes, I have created so many roles, so you can simply ignore it. Let me just create a new role. And this role will be AWS service, like what type of, you can say, who is the user, like who needs the access, who needs the role. I will simply say AWS service. Do I need AWS account? No. Web identity? No. 2.0 federation? No. Custom trust? No. AWS services, because we are talking about the roles for AWS services. Perfect. So I want to provide the role to what? To Glue. So I will simply search Glue. So this is the Glue. Perfect. And then I will simply go to next. Then I need to provide the permission. And what permission we need? S3 full access. Perfect. Now I can simply say next. Then this is the role name. I can simply say Glue to S3, or let's say Glue access S3. That means Glue can access S3, and this is the permission, and that's it. Let me just simply say create role. So now do you know what? This role is created, Glue access S3. If I open this, now what will happen? Whenever I will be creating my Glue instance, that will be creating very soon, whenever I will be creating my Glue instance, and if that Glue instance is talking to S3, which is a very common thing, I need to attach this role to my Glue. Why? So that Glue can talk to the S3 bucket. And we just have taken an example of Glue and S3. There can be any you can say technology. It can be Glue, it can be Lambda, it can be literally anything. It can be Lambda as well. Simple. So for that we will be creating a new role, because current role is just for Glue. Then we will create a new role for Lambda. Simple. Perfect. So this is the concept of IAM, and see, all done. This is the whole concept of IAM. I know like IAM is a kind of that particular thing. Hey, it is so complex. Hey, it is for seniors. We cannot understand it. But now I hope that my examples and my visuals are able to understand, are able to make you understand this complex topic. I hope so. If yes, do let me know in the comment section, because I loved this particular explanation for IAM in detail. And don't worry, all of these things will be available in the notes. So you do not need to worry at all. You do not need to just write anything. Simple. Perfect. Now let's try to understand one of the most important concepts exist in the AWS world. Not in just AWS, it is like the most important concept in all of the cloud providers journey. But we are covering AWS, so let's try to cover it from the AWS lens. Okay. So what is that topic, Ansh Lamba? This is like one of those topics that I love to talk about. And it is called... Any guesses? Any guesses? Any guesses? Ansh Lamba, no guesses, just tell us the topic quickly. Okay. It is called virtualization. Virtualization and hypervisor, basically. This is the most important concept, because why it is the most important concept? First of all, let's talk about this. Because everything that you are using in AWS, somewhere directly or indirectly, you are using the servers. Plus, in order to perform all of the data engineering tasks, you need to work with the virtual machines, or you can say virtual servers. So in order to do that, you need to understand this concept in detail. Detail means in detail, non-negotiable concept. Perfect. Very good. I have seen like lots of data professionals skip this topic, but this is one of those topics that you cannot skip. Virtualization and hypervisor. First of all, let's talk about virtualization. So virtualization, like what is virtualization? Because virtualization is like just a generic word. If you just look at the word virtualization. Okay, perfect. So let me just give you a hint. We are talking about virtualization from the server's perspective. Now just try to think about it. Now just try to basically look in front of your eyes. So virtualization means, first of all, virtual, which is not real, right? Perfect. So virtualization means we as a developers want to virtualize the server. Okay. How? So let's say I have this big server, like very big server. Let me just take this one. So let's say I have this, not I, basically let's say AWS has this one. Okay. So AWS has a very big server. Now, first of all, Ansh Lamba, what is a server? Server is basically nothing but just a machine similar to your laptop or computer, but this machine is much more powerful. Powerful as in more RAM, more memory, RAM and memory, same thing, more ROM, storage, more processors. So this, you can say, this is, yes, just a single machine, but with much more configurations, with much more, you can say, processors, RAM, everything. Simple. This is like very, you can say, powerful machine. You can just combine the processors, RAM, ROM of your entire area, of your entire street. Okay. And in reality, it will be like much more than that. But let's say, just for the small example, you can just combine all of the laptops and computers of your entire street or area. Then it will become one server. But under the hood, server is also a machine, but much more powerful. So what we do, virtualization means, bro, this is such a big machine, like, right? Like not in terms of size only, but yeah, in terms of power as well. So virtualization allows us to create small machines from this particular powerful server. So that means, what can I do? I can literally grab or basically create these machines, these virtual machines from this big server. Wow. Make sense? Let's say I want to create these machines from this big server. I can create that. And it is very easy. Simple. This is the whole concept. So now, Ansh Lamba, first of all, like, okay, this is the concept. But why do we need to create so many different machines? Why can't we create independent machines or individual machines? Very good question. And before answering that question, let me just expand this concept a little bit. Then we will just talk about that as well. And let's do both of the things together. So let's take an example. Let's say you have your laptop. Perfect. Yes. You are using, let's say, Windows machine, or let's say Mac. Perfect. Very good. And you have a very good personal computer, powerful, more RAM, everything more, right? Now you want to perform one task, or not just one task, you want to build something, but that development will require, let's say, Linux. Okay, Linux kernel. Basically you want to install Ubuntu operating system on your machine, or vice versa. Let's say you have Windows, you want to do something which will require Mac, or you have a Mac, you want to do something which will require Windows. You have a specific use case. Okay, perfect. So now in this particular scenario, you have two options. Option number one is you can purchase a new machine, obviously, with Windows operating system, obviously, right? You can do that. Second thing is you can use your server, basically your machine, which is also a server, okay? You can use this server and you can create a small machine from that particular piece. What? Can we do that? Yes. This is the concept of virtualization. Oh, so let me just write it for you. So let's say you are a user. You can create a small virtual machine from your normal PC, Windows, or let's say Mac. Make sense? You can create a small virtual machine from your normal PC, whatever you have, no matter you have like Windows or Mac. Simple. Simple. So this is the concept of virtualization, that you can do that. Now let me just answer that question, like, why do you need to do that? First of all, earlier, before cloud, when we didn't have this big servers and we were creating virtual machines or VPS from cloud, we used to do this thing. Let's say I have an organization and obviously I want to create multiple machines out of it. Sometimes I need to create Windows, sometimes I need to create Mac, rarely. Sometimes I need to create Linux machines, right? In those scenarios, instead of buying these machines, I used to buy a big server, right? I used to buy a big server. And from that server, as per my requirements, I used to create these small machines. Using what? Using a specific software, and we will talk about that as well, but you can just call it as XYZ software. Perfect. Okay. And I used to create these small machines on my own, using my own server. Perfect. Now after cloud, what happened? We do not need to first of all buy a server, which is expensive, right? Which is expensive, obviously. Second thing, I don't need to manage the server. Make sense? Now what happened? AWS came into the picture. AWS said, bro, what do you want? What do you want? You want machines? Okay, let me buy the server for you. So AWS buys the server, and it has already bought so many servers, so you do not need to worry at all. So obviously in the beginning, AWS started buying more and more servers. Make sense? So AWS bought the server, big server, like very big server, very big server. You cannot even imagine. You cannot even imagine. Okay. So AWS bought this thing. Makes sense. And AWS said, let me own this server. I will own this server. Perfect. Now just tell me this thing, that what do you want? Do you want a Mac machine? Yes. Okay. I will give it to you. Do you want a Windows machine? Don't worry. I will give it to you. You want Ubuntu? I will give it to you. So now you make a request to AWS. But now you do not need to create these machines manually. Now AWS creates it for you. Okay. Concept is clear of virtualization, like what exactly is virtualization. So in virtualization, the best part, if you have observed, because I have literally specified this thing multiple times, each machine will have their own operating system. That is the most important stuff that you should know. Own operating system. They will not share the operating system. No. So they will have their own operating system. Make sense? Okay. Perfect. Own OS. And here they share the RAM. Shared RAM and other things. Shared RAM and other stuff. Okay. Because each computer is connected to this server. Makes sense? So everything is shared. But yes, when you create this machine, you do not feel it like shared. Why? Because you allocate some resources. Let's say you say, I have total 100 GB of RAM. You take 8, you take 16, you take 32. So you have some dedicated quota, but everything is shared from this server. Make sense? Some allocation is there, but it is shared. Same thing is here. AWS owns this server. It has amazing RAM, amazing memory, amazing everything. Then you simply ask for, let's say I want to create Windows. Whatever window you want. Okay. I want Windows. I want, let's say 8 GB of RAM. I want 1 terabyte of storage. I don't know what you want to do with the storage, but still, let's say you asked for it. So everything will be created for this, and this is allocated storage. But yeah, everything is coming from the shared server. Make sense? Shared resources. Perfect. Shared resources. Okay. And these are the allocated ones. Perfect. OS is Windows and allocated resources. Perfect. This is the concept that you need to know. Or let's say resources allocated. Perfect. Make sense? Understood the concept? So this is the most important thing, that every machine will have its own operating system, and obviously it has like own operating system. So each machine will be isolated from the other machine. What did I say? Each machine will have its own operating system, and each machine will be isolated from the other machine. Simple. This is the core concept. Now, remember that software that I talked about, XYZ? Now let's talk about that. So everything that we are doing right now, everything, like we are creating small machines, we are breaking down this big server into isolated machines, right? We are creating one operating system on different machine, totally different operating system on a different machine. So how we are able to do that? Is there a magic? Is there any magic? Yes or no? It is hypervisor. Hypervisor is a kind of software that allows this particular magic, that performs virtualization for us. Make sense? It performs virtualization for us. Okay, makes sense. So what are the popular hypervisors we have? For on-prem, we have VirtualBox. If you have ever used VirtualBox, we have VMware. And by the way, before that, let's discuss like that basically two types of hypervisor. Type 1, which is not very important, but if you know this concept and if you just can learn this concept in 2 minutes, so what's the harm in doing that? So type 1 and type 2. In type 1, there is a dedicated software layer built on top of your shared resources, basically on the top of hardware. And very good examples are VirtualBox. That's why these are not very fast, but still like it is good. Then we have VMware. There are like basically two types of VMware, so do not start debate that hey, VMware is type 2. Not actually, there are two types of VMware. One is, I think, is the normal one, workstation, and the second one is VMware ELSXCI, something like that. That is like type 2. So there are like two types of VMware. Okay, so I do not remember the exact name, but yeah. So VirtualBox, VMware, and here we have Hyper-V, which is by Microsoft. We have VMware again, but of different type. Okay, I think we have EKS as well. I don't know if we have, like, you can just check on Google if we have EKS as well. So basically, in a nutshell, hyperware is the software that makes virtualization possible. Makes sense? It creates virtual machines, it allocates CPUs, RAM, everything that you need. All those stuff will be done by hypervisor. So if there is no hypervisor, there is no virtual machine, because hypervisor is the process, is the power. Make sense? Make sense. Okay, so let me just remove it because I do not know the exact name of this, because I forgot the name. So let me just remove it instead of giving the. So type 1, type 2, perfect. So these are basically the on-prem one before cloud, and these are also like on-prem. You can use Hyper-V in your machine as well. So now the point is, which kind of hypervisor cloud uses? They use, like I know about Azure, they use Hyper-V. Let me just check what AWS uses, because we do not actually need to worry about what hypervisor software they use, because they manage everything. But this is the knowledge that you should have. Make sense? Virtualization and Hyper-V, perfect. Now you are good to understand this concept easily, and I do not even need to explain this, which is called EC2. Now what is EC2? What is this name? Let me just write AWS EC2. So what is this thing? Like, what is this name? AWS EC2. Let me just show you. AWS EC2, and now you will read and you will understand everything. Yes. So let me bring the screen. So they are saying like why EC2, and we need to understand what is EC2. Okay, let's read why. So Amazon Elastic Compute Cloud. So EC2 means there are two C, Elastic Compute Cloud. In a nutshell, EC2 is a cloud virtual machine that we can use using AWS. Simple definition. Now you can read why Amazon EC2. Amazon EC2 offers the broadest and deepest compute platform with over 1,000 instances. That is amazing. Instances means each type of machine, because you would have used Windows, but in Windows there are so many versions, 10, 10 Pro with something else. So there are so many combinations. So they have 1,000 combinations available, and choice of the latest processor, storage, networking, OS, purchase mode, everything. And you can even you can say ask for a specific graphic card if you want, NVIDIA or anything. Like, they have everything available. I told you that they have like big servers, big server. This is like the, you can say, flagship product of each cloud provider, and obviously of AWS as well, flagship product. And I'm so sure that they would make the biggest profit out of these, you can say, services. I'm not sure because they didn't share the revenue report with me, but yeah, still I'm so sure about that. Make sense? Okay, so now we know what is EC2. EC2 is Elastic Compute Cloud. Simple. Make sense? Okay. So now let's jump on our, where's my AWS? Here it is. So now what we need to do, we will simply create our own EC2. Yes, it will be fun. So let's create first EC2, and you will simply go to the search bar and simply search type EC2 and click here. As you can see, virtual servers in the cloud. Click here and you will land on this dashboard. Perfect. I would have already created, I think, 1 to 2 machines, not sure. Let's see. Let me click on launch instance because we want to launch an instance, right? Or you can do one more thing. If you do not want to click here, click on instances, and then you will see all of the instances that you would have. I created one instance. I remember I was just testing something. So let's try to create a new instance right in front of you. So what you can do, you can simply say launch instance, and here exactly you need to do. First of all, server. What type of server you want to, like, what name you want to provide to your server. Let's say I want to provide Ansh EC2. Make sense? EC2, yeah, EC2. Then I have all of the instances available. I know there's a long list, but we can just pick from the quick start. Okay, if you click here, you will see the long list, but you can only pick the machines which are available for the free tier. So Amazon Linux kernel 6.2, then deep learning base AMI, then deep learning OSS. There are so many machines, right? If I pick Mac OS, there are so many versions available for Mac OS. If I click here, see Mac OS Tahoe, Sequoia, Sonoma. I'm not a Mac user, so I don't know the names. So let's say Windows would have like much more options available. Yeah, Windows Server 2025 base, core base, so many things, right? So now I want to create a Linux kernel machine, basically Ubuntu style machine. So I can either create Ubuntu, which is this one. I can also create Amazon Linux. So if you do not know the difference between Linux and Ubuntu, basically Linux is the kernel, is the engine. And on top of it, when that kernel is combined with your terminal, your UI, your commands that you run, I think that is called as GNU commands, GNU utilities. I do not remember the exact name, but yeah, it is called something like that. So when you combine the kernel with those things, it becomes Ubuntu, because Ubuntu is a kind of distributor of Linux. And obviously you cannot directly work with the kernel. You need those things to interact, to talk to the kernel. So Ubuntu packages everything and provides you that machine. Yes, Ubuntu is one of the most popular, you can say, open source software operating system available for kernel, but there are some other distributions as well which are very popular. And Amazon Linux is really, really popular in AWS space. So people I have seen do not go with Ubuntu, they just go with Amazon Linux. And let's go with this as well. So what we can do, I will simply select Amazon Linux, which is a kind of Ubuntu machine or equivalent to that. Okay. So I have architecture, I have instance type, I have key pair. So here you also need to create a key pair. If you do not have key pair, I think I would have created one, but you can create your own key pair as well. So click on create new pair and you can just create a new pair, just put username and password, and that's it. I think it will also download one file, but we do not need to do anything with that file, but just keep it, right? Everything is fine. Then, okay, this is important. I can allow HTTPS traffic and HTTP traffic as well, because if you just want to, let's say, hit any endpoint to that particular machine, so I would need HTTPS traffic, right? And specifically HTTP, not HTTPS, but yeah, HTTP for sure. And we need to allow SSH traffic from anywhere, because let's say if you want to connect it through SSH client, you would need this thing as well. Okay, so here we have configuration, 8 GB storage is enough because we are not doing actually anything. And we can also add new volumes, but this is fine. Number of instances, one is enough because we are simply learning it. Then click on launch instance and you will see within a few seconds, existing pair. Okay, let me just select this one. And you will see within a few seconds it will launch your machine. Forget about like going to shop and purchasing a new one. So it is done. Wow. Now I can go to instances. I will see there are 2 servers running. One is obviously stopped. So let me just open this one. Just click on this ID. And here it is in the running state within a few seconds. Wow. Literally wow. So now what I can do, I can go to public IP address, but obviously I will not see anything because I have not created anything. I have not put any API, any front end. I would have done that, but I didn't do that. So I will obviously not see anything. So what I can do right now, I can click on connect because I just want to connect to my machine, and then I can just do all of that stuff. So now what I can do, I have like these options: EC2 instance connect, session manager, SSH client, EC2 serial console. So this is the option that requires putty if you have Windows. If you have Mac or Linux machine, it is very easy. It is like just one line command. But if you have Windows, you can download putty to connect to it. That is completely different thing. We are not discussing that, but we can simply use AWS client to connect to that machine. It is much more easier and flexible, and most of the time in the organization as well, like you would just prefer this one over anything else. So here I can choose a username, and by default it is EC2-user. In your case it will be the same. Click on connect. So now let's wait. So it will simply connect my client with the machine. Boom, this is my machine. Ansh, Lamba, is this a machine? Bro, Linux machines are like this. You do not need to rely on the UI because Linux machines are for developers. They do not need to use UI. So this is my machine, and this is Linux machine that we have just hosted. I can also show you pwd present working directory, which is inside home. I can show you cd ... and then ls, and then cd ... ls. So these are all the folders that I have within my machine. I can literally do anything. This is my machine. So you can imagine this machine as just the machine without any kind of UI. Make sense? Like the way you use your machine using command prompt, same way. This is the terminal, that's it. If you just want to interact with anything, just do it with terminal. Make sense? Okay, let me just write exit. Perfect. Now it has logged out. Make sense? Simple. Was it simple? Let's go back. Let's click on EC2 for one more time. Let me just turn it off because I don't want to keep it up and running. And you should also turn it off. Otherwise, obviously it will spin up and then it will cost you. Obviously you have some free credits available, but why to waste? So go to instances and click on this ID, and then you can simply say instance state, stop instance, and skip OS shutdown. This option skips the graceful OS shutdown process. Use only when your instance must be stopped immediately, such as during an emergency. Or no, that's it. Simply stop it. Make sense? So now it will be stopping the virtual machine. That's how you create the virtual machine. Now let's, for fun, let's create one more machine. Okay, just for fun. If you want to just do it, you can. So I will say launch instances. Now let's this time create the Windows machine. There you will see the UI as well. So that's why I want to show you. Ansh Windows, and then you can simply create a window machine. And I will simply create a base one. Perfect. And here I will pick the existing key pair user. Okay, perfect. And this one, check. Okay, perfect. Okay, let me say launch instance. So let's launch this one as well. Boom. Click on instances. My third machine is also up and running within just a few seconds. So now this is my machine. So if I go to connect, this is not very straightforward. And again, this is not very critical or very complex. So this is session manager. If you just want to connect to Windows machine, you would need a remote desktop client, right? On Windows machine, you already get an application called remote desktop application. Exactly, you need to do it here as well. So just go to RDP client, and it will simply say connect using RDP client, yes, and download remote desktop file. So as you can see, download started. So it downloads the file, remote desktop file, on your PC, and then you can open that file and it will connect your machine, your client, to the actual VM. Let me just do that. Let me just go to my downloads folder and let me just double click on my file that I have simply downloaded. And let's see, let's wait what happens. Or if you do not want to open that file directly, because some systems can block you from opening that file, because by default, due to security concerns, all the system do not have like you can say permission to directly open the file. So in that particular scenario, you can just open your remote desktop application, which looks like this. remote desktop connections like this. See, simply search remote desktop connection. It is just for Windows. So if you are on Mac, you can just find the alternative. But even if you do not want to do it, just watch it for tutorial and that's it. So here it is asking me for the PC name. So this is my public DNS and I can click here and I can provide it. Perfect. Let me see, connect. And now it will ask me for password. Password is, by the way, username is administrator. I don't know why it has picked Ansh Lamba, or maybe it has just automatically detected it, maybe due to public DNS, but that is fine. That is fine. Now password, I don't have password for now, but I can generate one. If I just click on get password, let me just get the password and then I can just fill it there. So here, then it can just ask you to provide the private key file. So if you do not know, because some people can just skip the part of creating the key value pair. Remember, just we created this key pair associated with the instance. You can actually go to this one. So key pair name copied, and you can upload the private key file, because whenever you just create the key value pair, it downloads a file called .pem file. And when you just upload that .pem file, only then you can just decrypt the password. Make sense? It's simple. I'm just telling you, if you just, in case you are confused like what to do next and we are stuck. So here I have just put my username, which is administrator, and password. I have already told you how to get the password, right? So let me just click on OK. And it's saying blah, 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 blah. Yes. Let's see. Okay. So this is the tab. Let me just open it. Wow. My new virtual machine, Windows, and here you will see the UI. Don't worry at all. This is the exact machine that you use on a daily basis. So yeah, that's how you can just create machines like this, personalized settings, setting up personalized settings. And this machine will not be very super fast, because this is like very basic machine, only 1 gig of RAM, 8 gig of storage. Do not think of installing Vice City on this machine and playing it. Do not, like, you can, because you have the freedom, but you can just create this server and you can literally do anything. You can host your SQL database. Wow, this looks amazing, man. So I have recycle bin, some garbage stuff. And where is my that thing? Oh, okay, I can expand it. I can just click on Windows, and yeah, like, you can just play with it if you want to. This will be like very, very slow. I know it. It will take some time to load it, because this is very, very slow. See, now it is like black. Because in Windows, the problem is you need to allocate the resources for UI as well. That's why the developers, the core developers, do not use Windows machine a lot. Like, see. Okay, Windows lovers, listen to me carefully. You can use Windows machines to build your applications, to build your solutions in data engineering, to host everything. I am saying that whenever you want to go with the Windows machines, you need to allocate some resources for the UI, and it incurs some cost. If you are working in a bigger organization, they do not care. They can just simply say, hey, do you want this much of money? Okay, take it. Okay, you want more salary? No, it is not allowed. So they can spend more on the resources, but they cannot spend more on your salaries. That's a fun fact, but yeah. So from that organization perspective, you can just spin up Windows machine and you can just do the stuff, because obviously when you have UI, it is easier to work with the stuff. You can easily create folders. You can easily see what is going on. But if your budget is not that much, and if you still want to achieve everything as you do, you can just spin up a Linux machine, basically Ubuntu machine, and then you can just interact with that machine using the terminal, because there the machine is fast because no UI is involved. And see, again, the screen is like blank. But yeah, I can do anything that I want. I can simply go to Windows. I can just install anything if I just want to install anything. Like, this is your machine that you usually use in your system. And choice is yours. Sometimes people with low budget still create Windows machine, because I know when you have UI, you can maintain the machines better. You can take backups better. It's your choice. Okay. Now I hope that you have a 100% knowledge about EC2, how to manage, create and scale it. Obviously, you do not need to scale it, because all the scaling will be handled by AWS. If you want to scale up, you can simply do it automatically, and you can just define the rules because on the basis of load balancers rule, you can just scale up and scale down. Simple. Okay, good. So now let's try to understand very important concept. Okay, because this is not very hyped right now, but this is the base for all the, I would say, interview questions related to data lakes and all those modern, you can say, advances, yeah, whatever. So now the question is, before question, let me just write AWS, I think EB8, not EB8, Elastic EBS, not 8, EBS, AWS EBS. What is this? AWS EBS. It's called Elastic Block Storage. Elastic Block Storage. Perfect. Now what is this Elastic Block Storage? Before understanding this concept, you need to understand what is block storage. So let's try to discuss that. Because cloud is just cloud. You can build your own cloud. It's not a big deal. Okay. We are using cloud because we do not want to do that boilerplate code thing again and again, like boilerplate stuff, like buying the stuff, managing it. But under the hood, cloud is not doing something magical or something out of the box. It is simply replicating the stuff that we used to do on on-prem. But now the thing is, people are not understanding that what we used to do in on-prem, they are directly learning the stuff in cloud, and they think like everything is cloud is doing, like it is not possible in on-prem. Cloud is just allowing you to request the services through APIs, and that's it. You can build your own cloud. It's not a big deal. Yeah, you need some smart brains for that, but it's possible. So AWS EBS. Ansh, Lamba, should I just start my own cloud? Who is saying this? So AWS EBS. Before talking about that, let's talk about block storage. See, I think Geo is very aggressive on building cloud. I do not know about the clarity, but if we get our own cloud from Geo, it's gonna change the dynamics. Then we'll be teaching Geo cloud. Geo cloud fundamentals for data engineers. See, it is what it is. It is what it is, right? It's not a big deal to create a cloud, especially for him who has like everything to build. So block storage. Now what is block storage? So let's start the journey with you. So let's say you are a user. Okay, you are a user who uses laptop, computer, whatever, any system. So let's say you are using your system and you are dumping any data. Okay, you upload a file, right? This is your personal computer and you upload, let's say, a CSV file, or let's say any Python file, or any file, let's say Excel file. Make sense? Or let's take a text file. It will be a better example. Otherwise you will be like confused. Hey, what does it mean? Let's say doc file. Perfect. So you uploaded this doc file into this system. Simple. So far, perfect. So now what will happen? Let's say the size of this file is 100 MB, let's say. Perfect. You upload this file in a folder called, let's say, my data. Perfect. And within this my data, you have the file called, let's say, document.txt. Simple. Okay. So far, yeah, it is simple, bro. Don't worry. Okay. Okay, perfect. So this is the kind of hierarchy. Simple. Let me just remove it. It was better before that. So we have this folder, my data, and we have this particular file called my document, or basically document.txt. Perfect. So now just let me just ask you one question. You uploaded this file. It is saved. Perfect. Now when you just try to open this file, what do you see? Ansh, Lamba, I just see my document. Perfect. But you know what? You will think that your system saved this file as is, and when you just double clicked on it, you saw the results. That's it. But that's not how block storage works. So when you upload this file, this document, so I would say in reality, this file will be first of all broken down in the form of small blocks. Let's say block 1, or let's say block. Small blocks, very small blocks. Okay. Makes sense. So first of all, these will be converted into blocks. Who will convert it? Operating system, OS. Operating system is not just for your fancy UI, it performs the stuff as well under the hood. So this will be converted into blocks. Convert into blocks. Perfect. So now these blocks, and what will be the size of blocks? I think by default it is like in KB something, but yeah, you can just check the exact size, and obviously you can just make some tweaks, and I think it also varies with the every Windows upgrade as well. So if I cannot just quote the exact number, but it is like in KBs, I'm so sure. So your data will be broken down into blocks. Okay. So now when you want to access this file, let's say you are a user and now you want to open this data, right? Now you just opened your system. Now you want to access. Okay. Wanna see the file. Okay, makes sense. Now you wanna see the file. So now do you know what? This operating system, what it will do? This OS. Operating system, Windows, Mac, whatever, Ubuntu, it will find all the blocks and resembles them together. Wow. Yes. So what it will do? It will, like this OS will, let me just move it here. Perfect. So it will resembles the results. Okay, under the hood. Or let's keep it here. Perfect. So now this OS will resembles all of these blocks, And now you will say, Ansh, Lamba, how does it know like where the block is stored? OS maintains the metadata as well. Okay. Perfect. Makes sense. Makes a lot of sense. So now what it will do? It will simply, let me just connect it like this. Perfect. So now what it will do? It will simply say, resembles all the blocks. Perfect. And now these blocks will give only one file in return. Make sense? In return, this will get only one file. Okay. So let's say this will give only one file, the full file. Okay, makes sense. Makes sense. And let's have some space like this. Perfect. And I hope you can just see this. Yes. Perfect. So it will return this full file, which is document.txt. Simple. In return. And now this file, this full file will be displayed to the user. That's how it works. I hope it makes sense. That's how block storage works. Returns full file. But you do not see these things. You do not see these blocks. Why? Because operating system is actually doing all of these things for you. Makes sense? This is the concept of block storage. Here, if you just notice one thing, you need to have operating system in the picture to manage everything, to manage metadata, to resemble all the blocks, to show only one file, everything. Simple? Very good. So this is like on-prem behavior. Now, if you just move to cloud, what will happen? Same stuff. Same stuff. So cloud, what cloud will do? Cloud will simply take your data, right? And it will just create multiple blocks and it will assign one virtual machine because you need to manage the operating system as well, right? So it will do the same thing for everything that we have just discussed. Same thing. Make sense? So now let me just show you AWS EBS. AWS EBS. So here, provide scalable high performance block storage volumes that attach to Amazon EC2 instances. See, EC2 instances, and we already know what are EC2 instances, virtual machines. So they attach this disk. You can just treat it as like a hard disk attached to your EC2 instance or basically virtual machine. It can be obviously HDD, SSD. It depends what type of hard disk you want to create. So it is for VMs. Yes, you can just use it to store data, but it is actually connected to VM. You cannot access it without VM, without operating system. Make sense? So you cannot just store data into this particular service and you can access it. Not really. You can attach these, you can say disks, hard disks to your virtual machines, because what you will do, you will attach this disk and you can just access your virtual machine and through any connection, and you can just access the data through the virtual machine, right? Through the operating system. Perfect. So this thing is perfect. Makes sense. Now, do you know what? We do not work much with EBS. Why? Because we are data engineers. Yes, we work with elastic block storage when we need to create the virtual machine, but after that we do not work with that much. We simply ignore it, because once the virtual machine is there, once we know that our machine is running fine, we rarely upscale or we rarely add any kind of block storage. So it's like once in 2 to 3 months task, once in 6 months task. It's like that. But there is one more service which is like, you can say, one of the hottest service that we use. I would say once in a week. We like create data lake so much. Let's talk about that service. This service is called, first of all, AWS S3. So now if you're coming from the Azure background, in Azure background, you will see two different services. One is Azure Blob storage and one is Azure Data Lake Storage Gen 2, right? But in Amazon, we just have S3. Simple. So what exactly is S3? S3 is the data lake solution. Ansh, Lamba, do you know what? We have literally heard this word data lake everywhere, but now today we want to understand this. You want to understand this? Okay, let me just explain you. So now we are just talking about S3. Okay, let me just bring that cute symbol for S3. I love this. Perfect. Let's try to understand S3 in detail. Makes sense. Now, do you know what? Before understanding S3, let's try to understand data lake, because once you understand data lake, boom. See, here you understood the concept of block storage, you understood EBS, boom. So that's how you learn. That's how you learn. You are becoming an efficient data engineer on this channel. You are not here to just remember the definitions and that's it. You are here to become an efficient data engineer, okay? Because you are representing our community, our data fam community, bro. If you are representing, if you are the part of our data fam community, and if you want to become the part of our data fam community, join us, bro. Join us. We always welcome those people who want to do something in their life. So now let's talk about the something called as data lake. But you know what? We first need to talk about blob storage. What is this? Yeah, that's an expected question. What is this? Because no one actually talks about this thing, and data lake is nothing but just the blob storage. So blob storage means binary large object. Blob storage, binary large object. Okay, now just tell me one thing. What is the pain point here in our normal block storage? Pain point is, let's say I want to store some data, right? And I want to access it as well without any kind of virtual machine. Okay. Because see, yes, I can store some data into the disk, into the block. And if I want to use it, I have to log into the virtual machine and then I can access it, right? I want a solution where I can put my data, right? And I want to access it without a virtual machine, without an operating system. That's where the concept of binary large object come into the picture. So what is so magical in Blob that we can access the data without VM, without OS? What is so magical? So nothing is magical actually. So binary large object actually uses the concept of block storage under the hood. Yes. So what will happen? You will dump your data, remember? Yes. And here you will dump your data in the virtual machine, first of all. Not like virtual machine, basically directly on the cloud, because Blob is built in cloud nowadays. Earlier people try to build their blob storage in on-prem as well, because these are just the APIs, but nowadays we do not build those on-prem blob, you can say APIs. So you can just imagine that we are dumping our data in the cloud. Make sense? So here I can build, let's say, blob storage. I think I should have Azure blob storage. We are learning AWS Ansh Lamba. Okay, makes sense. Let's say S3. Yeah, let's say S3 because S3 is also like a kind of blob storage. Yes. So let me just use this one. So let's say I want to dump my data into the S3. Okay, called document.txt. Perfect. Now what will happen? Same thing. This will create multiple blocks. Yes, concept is same. Fundamentals are same, bro. Convert into blocks, or here you can say chunks, because blocks are for block storage. You can say chunks, but the concept is same. We just need to divide our data, right? Perfect. Chunks. So now what will happen when we have data divided into chunks? Now these chunks used to be called by operating system because they had the metadata, but here do you know what? Here, because of like cloud, you can say solution that we have, here we do not need any kind of virtual machine. Really, yeah. Here we do not need any kind of virtual machine because here we have something called as parallel nodes. Okay, parallel nodes. And parallel nodes means you have basically the distributed storage nodes. So you do not need OS, you do not need file system, you do not need anything. Basically, you do not need a virtual machine. Okay. So what is the benefit of distributed nodes, or you can say distributed storage? The advantage is anyone can access these chunks. Anyone can access these chunks. So there is no need to just combine the data every time. Let's say I just want to use these two chunks only. I don't want these three chunks. So that is the advantage of it. Sometimes, yes, we need to just combine all of the chunks. That's a different story, but that's not the, you can say, necessity. Are you getting a point? So now Ansh Lamba, if we do not need any kind of VM, yeah, how do we access this data? All of this data is accessed through API, not via mounted disk, because you do not open files, you request the objects. Make sense? So now let's say I want to access it. Let's take the same example. So here, let's say you want to access the data from obviously S3 here. So what will happen? You will simply request. Want to see the data? It will request it through the APIs. So let's say these are the chunks, right? So it will request. Request through APIs. Make sense? So you are not opening the file by double clicking on it. You are requesting through APIs that you need this chunk, you need this chunk, and that's it. Here it is block, but yeah, same thing. Blocks or chunks are same things. Make sense? And in return you get the data. Are you getting a point? Request through APIs. Okay, because you request the objects. Okay, makes sense. So here you do not need any kind of virtual machine or operating system. Okay, makes sense. So if I just need to sum up, I can simply say that block storage, on-prem or cloud, I do not care. Block storage rely on operating system, right, to map the, you can say, blocks and everything, but block storage simply relies on VM. You can say those operating system and stuff, but in short it relies on VM. And if it is your on-prem, it is just the machine. It relies on machine, but here it does not rely on anything. Simple. That is like one like summary, right? And what is the reason behind it? Because it stores files as distributed chunks managed by the storage service itself. Make sense? It stores files as distributed chunks managed by the storage service itself. Let me just write it for you, otherwise you will forget. So here is the quick summary that I've written it for you. So now you will say, Ansh Lamba, okay, blob storage is done, but as you said in the beginning that in Azure we have like two different services, Blob and Azure Data Lake Storage Gen 2. Okay, in AWS we just have S3. And what is actually the data lake then? So now let's talk about the data lake. So what do you mean, like, is it like different? Not different. When we just enhance blob storage a little bit, it becomes data lake, but it is the blob storage under the hood. Okay, so I can simply say data lake, or you can say enhanced blob storages. So I can simply say enhanced blobs. Okay. So now what happens when we just store the data in the blob storage? We directly store the data in the form of files. We simply dump the data. That's it. We simply create the blobs, right? But when we just want to perform the big data analytics, we need to store the data in the form of, you can say, folders. We need to maintain the hierarchy, because let's say we want to say, hey, this is the sales folder and we have all the sales data. Hey, this is the let's say categories folder and this is the categories data. But in Blob, it is not possible. It is not possible. So in AWS, we just have one service, which is like enhanced blobs. But in Azure, we do have like two different services, one for blob storage and second one is for data lake storage Gen 2, because I think Azure first created blob storage and they didn't enhance the previous one. They simply launched the new service called data lake storage Gen 2. But yeah, it is what it is. Make sense? So it is blob storage under the hood. Blob storage, but it also allows let's say hierarchical folders, right? And it also allows ACLs. If you do not know about ACLs mean, let's say you want to just restrict the permission, fine grain it, you can do it. And I think what else, like, because everything else is same, but if I would find anything, you can just do it, because you just need to understand the concept. From the theory perspective, you can just learn as much as you can. There's no limit to that, but now you need to understand it. Like, it is blob storage, but you can just store the data in the form of folders. Make sense? And obviously in the world of big data analytics, we want to just store the data in the form of folders. This is the concept of data lake. Now this data lake, enhanced blobs are nothing but your S3 bucket. Understood? S3 bucket? See, that's how you understand the concept. This is very important. All these concepts, these are like fundamentals of, you can say, data engineering. You need to know all of these stuff, right? Blob storage, block storage. What is this thing? I know it is very easy to just create S3 bucket, boom, dump the data, boom, read data, boom. Bro, how it is storing the data? How you are accessing the data? How you are just seeing the data? How? You need to do all of these things. And then they say, data engineering is complex. It is not complex. You need to follow things in a guided approach. You need to learn step by step, right? And don't worry, now we know. Okay, so let me just quickly open my S3. Where is my S3? Where? Yeah, here, I guess. Yeah, perfect. So let me just open my AWS account. So here I will simply create a new S3 bucket. Simply search S3 and click here. By the way, S3 has recently launched, I think, vector search capabilities as well. So you can even create vectors within S3, which is amazing stuff. Azure has not enabled that thing for now, but yeah, S3 has enabled. So this is my S3 dashboard. I have some created ones already, just ignore. So here you will see all the things on the left hand side. Let me just increase the size. So you will see general purpose buckets, directory buckets, table buckets, vector buckets. This is the vector buckets. This is for AI engineering. Okay. And if you do not know about AI engineering at all, I don't know what are you doing. It's like 16th of January, 4:30 p.m. and I don't know what are you doing if you still do not know about AI engineering. And if you just want to learn about AI engineering, just check out my YouTube video. It's called, I think, Generative AI full course. It is for very scratch, very fundamental level Gen AI course. If you just want to learn about vectors and databases, that's it. Then you can also watch a dedicated course on RAG masterclass for data engineers, or I think RAG tutorial for data engineers. Just search the name, just simply type RAG Ansh Lamba, you will find the video. Just know about all these things, bro. You do not have time left, okay? Because competition gonna boom like this, and I'm not exaggerating. I'm just, you can say, asking you to be prepared, because the ones who are prepared, they do not need to worry at all. They feel happy when competition rises. Do you know why? Because they know when competition will rise, only those will be hired who will have the skills, and they already have the skills. So they are happy. They are happy. Because whenever competition rises, pay and, you can say, good offers, more flexibility towards work also, you can say, contributes to the, you can say, package. So they are happy who know all of these things. And I would say Let's talk for like 1 to 2 minutes. It's very good for you if you want to just understand the dynamics of what's going to happen. So for 2026, this is the last year. Okay, 2026 is the last year for the learners, for all the ones who just want to learn. So what will happen after 2026? So by 2026 end, all those, you can say, experimentations will be completed. What experimentations? As you know, like OpenAI, Gemini, Claude, all these big tech companies are just, Microsoft obviously, they are, AWS as well, they are just in the experimentation zone since I would say 2024, right? We are just seeing so many advancements, so many layoffs, so many things, right? They are still in the experimentation zone. They are not ready to cut down their, you can say, resources. They are still like doing that, but they are not mature enough to just lay off the resources like this. But by 2026 end, they will have a very clear picture what workforce they need to keep, who will be the real contributors to the organization, and who they just need to just lay off like this. And they lay off like this. They do not think about you, your family, whatever. They do not care. Okay. So by 2026 end, this question, or basically this, you can say, dilemma will be cleared. And then from 2027 onwards, you will see like chaos. Like people are saying like, hey, this company laid off this much of people, this company laid off this much of people. And then if I talk about data engineering only, data engineering, yes, is the most AI proof career for now in the AI bubble. Why? Because AI is dependent on data engineering. Data engineering is not dependent on AI. But still, data engineers are not just the ones who know to build data pipelines. They are the ones who can work with AI engineering, AI development as well. Are you getting my point? Roles and responsibilities will be changed or will be modified. Expectations are more. So now it's up to you. Like, I am no one to tell you that you need to do this, you need to do that. But I'm simply saying, if you are devoting your time in learning from, let's say, my videos, it is for your benefit. And choice is yours. Choice is yours. Choice is yours. And I'm not saying like who is doing what thing, who is like, you already know the industry, like like all the teachers, like what is going on in the market. So if you are getting some value from my videos, and obviously almost for free, right? So you can just support me and this channel. Simple. So let's quickly create our new bucket, and don't worry, bro, I am with you. Don't worry at all, and just trust this guy. Just trust this guy. So now let me just create a new bucket, and the bucket name I will simply pick, let's say, Ansh bucket, right? And this name should be unique. You cannot pick this name that I have picked. Copy settings from existing bucket, not really. We will just do everything from scratch. So this is the bucket name, and ACLS, remember I just wrote this thing, like we can just enable it as well, but we have for now disabled it. And we have blocked all of the public access because we do not want anyone to access our data. Because remember, I said that we can access our data through the APIs. And APIs are what? Anyone can just make an API call. So we have denied all of the public access. That means no one can access my data or your data or anyone's data on S3, right? So I will simply scroll down, and then we have bucket versioning. We can enable it. It's a very good feature, and let's enable it because I need to just tell you about this feature as well. So let's quickly click on enable. And we have tags optional, ignore it. And then this is fine. Bucket key, it's fine. And then click on create bucket. Oh, what? Ansh bucket is, name already exists. Who is this? Ansh bucket, let's say 2026. Bro, Ansh Lamba is just one and only. Who is this guy? So let me just open this S3 bucket, and this is my bucket. This is my data lake basically, right? So here you can see that I have so many options. I can see my objects, which is empty, and I can upload, but I can also see a special button called create folder. This is due to the data lake behavior, because we can create the hierarchical folders, right? If this would be just the blob storage, then this option should not be here. Make sense? Okay, good. So we will create the folder. We will also upload the data. Don't worry at all. And here we have properties, permissions, and everything. Make sense? So let me just quickly download the data. Let me first of all create a folder. and I will create a folder name, let's say source, right? Or let's say raw data. And here we have create folder. So here we have created this folder. Let me just open it, and now I will upload the data. You can upload any file, by the way, but don't worry, I will just also provide you some files, and I have already provided the files in my GitHub repo. You can just go and download it, right? And the GitHub link will be in the description, and just download the files from here. Let me just upload some files here. So this is the GitHub repo. I can just show you. First of all, yeah, this is my GitHub repo, and you can just click here. Where? Yeah, just click anywhere. Just click on repositories, and let me just change this. Like, it is so old. Like, I have added so many certifications. Like, I'm not like flexing on my certifications, but still. Yeah, I think I last updated this particular front page on, like, I don't even remember. Yeah, because I just create repositories for you guys, and see, let me update this. So this is the repository for this AWS fundamentals for data engineers, and if you haven't checked this repository, I would say this is a gold mine for you, this one. If you haven't checked, we already have like 519 stars. Wow. This is amazing. So just click here for now. You can just check it later on. And here we have a folder called raw, and we have two files, data1, data2.csv, and I will download these files, and you can also download these two files. Perfect. Simple. So let's upload these two files, and here, as you can see, add files, right? No files and folders, and I can drag and drop. Let me just quickly do that. Let me do that. Data1. So now I will simply upload only one file, data1, data1.csv, as you can see, and I will simply say upload. So this data is uploaded, right? See, this is the you can say API available for my data. Remember, I told you that we access data from the APIs. This is the API. Simple. Let me also show you by going here. So this is my objects. As you can see, I am inside this particular folder, and then raw. Basically, this is the bucket, and then this is the folder, and this is the data. Perfect. Perfect, perfect. Nothing fancy so far. Very, very simple things. Now, within this, we have one important thing that I just talked about, versioning. See, first of all, in the data lake, the biggest advantage, if I just want to talk about the data lake, because we already know, the biggest advantage is we can store any data, right? Any data. And this is the, you can say, heading, store any form of data. It can be your structured data, it can be your delta packet data, it can be your any data, textual data, videos, images, anything. So it can store any form of data. That is one of the biggest advantage. And currently, as you can see, we uploaded the CSV data, right? Textual form data. Makes sense? So you can literally upload images, videos, whatever you want to upload. Simple. It is similar to OneDrive. If you have used Google Drive, OneDrive, it is very similar to that. Simple. So this is fine. Okay. Now the second thing is versioning. What is versioning? And we have also enabled versioning, right? If you remember, if we go to properties, we should see that objects, or just go to this particular bucket, and here in the properties, bucket ABAC, not, oh yeah, bucket versioning. So it is enabled. See, we have enabled it. You can, if it is disabled, you can edit and enable it as well. So here we have versioning enabled. What is versioning? As the name suggests, so let's say you upload the same data, again, data1.csv, and let me just upload it just to show you. So if I do not have versioning enabled, so what it will do, it will simply overwrite my data. Simple, right? But this time it will not overwrite my data. Oh, okay. So what it will do, let me just show you what it will do. So this is my data, right? Okay, perfect. And let me just go to, first of all, here, just to show you like how I'm navigating. So this is raw folder, right? And within this, I have data1.csv. Now here, you just need to click on show versions, because by default it is turned off. Click here and you will see we have two different files. It didn't overwrite my file. It didn't just replace my file. It created a new version for my file. And by default, it always uses the most latest version, which is this one. Ansh, Lamba, how do you know? See, 442 and 439. The latest one is this one. That's why I'm seeing this one. And I can just turn it off so I can just see the latest version. Makes sense? But I can just access any one. I can just go download, I can modify, I can re-upload, I can do whatever. So the advantage is sometimes in rush, we just upload or basically overwrite the data. And being a data engineer, I know like we do this kind of thing a lot. Like in Azure, I have done it many times, but I know like how I have retrieved the data. So what I used to do, so let's say I am saving my parameters file in the data lake. So I used to just create a new version of it using my local text editor, and I used to just upload the data in the new location, like in the same location with the same name. So obviously it will just replace the file, right? So now in the new parameters file, I have an error due to any reason. Now I cannot go back, and because of some reasons, the experts of my team didn't turn on the feature of soft deletion enabled, because if we have soft deletion enabled, we can just retrieve the file back. So now, do you know what I did? I spent first of all 30, 40, 45 minutes and 1 hour to just figure out like what actually I did. Then I went to some, you can say, monitoring of my pipelines in the Azure Data Factory, because I ran the previous pipelines with the same, you can say, parameters file, and I retrieved the output of the metadata file, and I then extracted the text, and then I just modified it to the previous version. So we have workarounds, but it saves a lot of time if you have, let's say, versioning enabled, which is an amazing feature, bro, to be honest. So that's all about the versioning that we have within the data lake. Simple. So now I will just show you one more important thing, which is called S3 storage classes. This is something theoretical, but if you know all of these things, it's always good to just answer in the interviews plus in the development phase as well, but it is little bit theoretical. So let me just take you to the official documentation page, because if we just want to cover something theoretical, the best place is official documentation page. That's it. So I'll simply say S3 storage classes. If you are coming from the Azure background, it is very similar to the data you can say data access policies. Like if you just want to make it hot, warm, or cool, or cold, so it is very similar to that. So let's try to read about it. S3 storage classes. Okay, this is a better, you can say, UI, and I think I have one more documentation, which is this one. Understanding and managing storage classes. Yeah, this is also a good one. So now, long story short, I know this is like little bit theoretical, that I would encourage you to go and obviously read it on your own, but still I'm just guiding you, I'm just giving you the hands-on, I'm just telling you everything, so it's my duty to tell this as well. So what is the high level overview of, you can say, storage classes? So just tell me one thing. Let's say you are given a task where you want to, let's say, store some data, right? So just tell me one thing, that will you access all the data that you store? Obviously, Ansh, that's why we just store the data. You didn't get my question. I am saying, let's say I have given you the task that you need to store this data. You as an efficient developer, or you can say senior person, would have asked, okay, I can store this data, but how frequently you will access this data? That should be a follow-up question. Let's say I want to store the data that I will not access it, let's say, for months, because I want to just simply create a backup. I want to simply create an archive. Make sense? Okay. So in those scenarios, I do not need to just store the data in the pool, or basically in the location which is optimized for faster reads, because I will not be just reading the data frequently, right? So why I'm just paying for that? Exactly. So if you have different use cases to store and access the data, or you can say read and write the data, you can pick the best class for it. Okay, makes sense. So by default, we get this standard class, S3 standard, which is optimized or basically designed for frequently access data more than once a month with milliseconds access. So this is the fastest way to get the data. Availability 99.99999%. Okay. Oh, sorry, durability and then availability. By the way, same thing, almost. Availability zones greater than equals to 3. Remember, I told you that by default, AWS will create the copy of your resources into the 3 zones. This is exactly it is talking about. Then we have one more standard, which is, I think IA stands for something access, like inactive access, something like that. Like it means like you will not be accessing your data frequently. So let me just search for that exact word, IA. IA, where is that? Let me just say, the meaning is like you can say inactive access, you will not be accessing that data frequently. But if you just want to go with that exact, if you just want to learn the definition, you can just go and learn the definition. My duty is to just make you understand. See, infrequent access. Yeah. Make sense? So meaning is same. So if you just want to learn, you have infinite web pages to learn. Keep on learning and remembering the stuff. If you want to understand it, this is the place to understand. Okay. So, okay, makes sense. So the second class is infrequent access, standard IA. That means we do not want to frequently access the data. So this data is long lived, infrequently accessed once a month with millisecond access. Make sense? Then we have another class, it's called intelligent tiering. Now intelligent tiering means AWS will automatically decide like which class is good for you. It will like keep on monitoring your data. If you're not accessing your data for months, it will put it in the other class. So it is like, it's very similar to intelligent workload management if you are coming from Databricks, right? So it is very similar to that. By default, like in the background, they just want to say that we can handle your class, simple. So data with unknown, changing or unpredictable access patterns. Make sense? Then we have S3 one zone IA. That means they will not deploy your data, or basically they will not deploy your S3 bucket in 3 zones. They will simply deploy it in 1 zone. Okay. S3 one zone IA. Simple. Then S3 express one zone, single digit milliseconds, and then glacier instant. Glacier means like you do not want to just use your data. You simply want to archive your data. Simple. Then we have glacier flexible retrieval, long lived, and then this. Then we have deep archive. That means like you put your data and forget about it. Make sense? And we have these classes. So basically you can just read about these classes. You can just learn some of the, you can say, patterns, but the high level understanding is these are the, you can say, patterns, or these are the, you can say, use cases for the storing your data efficiently so that you do not overpay for the things. Make sense? And these classes, let me be honest, these classes will be keep on changing. Earlier we didn't have these exact classes, they added so many classes. So it's not something that you need to learn. It's something that you need to refer being a senior data engineer, and you need to refer to the documentation every time, if like whenever you want to take a decision. Make sense? That's how you can just refer to it. And if I just go to this documentation, this has some nice UI, and here you can see we have general purpose. For general purpose we have standard. So if I just click on plus, you will see that S3 has like standard features. And if I say unknown or changing access, we have intelligent one, right? Intelligent tiering. Simple. And if we have high performance, one zone, because it will not be deployed to multiple zone, and infrequent access, we have glaciers and all. For archive, we have glaciers, and here we have IA ones, infrequent access. Because infrequent is still like you are accessing the data. Archive means you are not using the data at all. Make sense? So this is a very good bucketing, I would say. This is a very good categorization. I would say just read this documentation, because this way you have like much more better understanding of the architecture. Make sense? Very good. Now one more thing we need to talk about the S3, and this is something that you should know as a developer. This would require some coding, but it is worth knowing. Okay, what is this thing? For this thing, you need to first of all install the VS Code or any code editor on your machine, okay, with Python installed in it. And I would expect, if you're a data engineer, if you want to become a data engineer, this would be the thing installed on your machine. I would expect this thing, right? So just quickly, if you do not have, just go to Google and just download Python with any code editor of your choice. Simple. Once you install that, let me just show you this amazing feature, because this is directly linked to your development that you will be doing as a data engineer. Simple. Okay, let's do it. So here I have opened my VS Code editor, and obviously you can see that you can just open any code editor, by the way. I just like to try new code editors. I just keep on trying. Currently I was just accessing anti-gravity more recently. There were some AI based code editors, so you can just use any code editor. It's not like restricted to just VS Code. And as you can see that I have created one folder called AWS_tutorial. You can create any folder, and this folder is empty right now because I will be showing everything to you from scratch. Okay, so let me just quickly grab my where's my whiteboard. Let me just bring it. So new window. Okay, perfect. So here is my whiteboard. Perfect. So now what we are trying to do, we are trying to learn and see the tutorial, which is very important from the development perspective. So what are we trying to do? We are saying that, hey, we want to access, or let's create a new heading, by the way, because this is a new topic in itself. And this is very important because once you understand this, you can easily work with any toolkit. Ansh, Lamba, enough suspense. Now we just need to know what are you trying to do. So I am saying access S3 with Python SDK. Make sense? And even before that, let me just show you how to access, or basically access S3 bucket, or not just S3, other resources as well. Any other resources, access S3 or any other, because right now we have created many resources. So now you should know like how we can access all of those resources, right? Access S3 or any other resources. But why S3 commonly? Because we access S3 more commonly than any other tool, right? So or any other let's say tool or service, anything, right? Or any other service. Perfect. So now there are basically three ways. Okay, the first way is very simple. It is called AWS portal, basically the UI, right? Simple. This portal, AWS portal. Perfect. So one way is this, and as I can just show you, so this is your portal. So if you want to access anything that you have created in your AWS account, you can access it using this particular UI, right? And yes, AWS has created an amazing UI for you. So most of the time you will be accessing resources from AWS portal itself, right? Good. The second way is, let me just grab my whiteboard. Perfect. AWS portal, or I would say AWS CLI. Perfect, because there are two things, but in both of the cases you will be accessing AWS portal, UI or CLI. Let me just write like this. It will be better approach. UI or AWS CLI. Perfect. So now you will say, hey, where is our AWS CLI? So first of all, this is not your generic CLI, right? This is not your generic CLI. This is, you can say, your, how can I explain this? Because there are two types of CLI. CLI, first of all, is like command line interface, if you do not know about this. So if you want to access anything for Azure, okay, oh sorry, AWS, so you can use CLI. But now here the thing is, command line interface is also available to you with the portal itself, okay? Or you can even rename it as, if you can be confused, okay? So you can say shell. So if I just show you that particular option, it's here. So if you just go to your any resource, or even if you click on your home page, right, you will see a button here. See, let me just zoom it a little bit. Can you see this button? Perfect. This button is called shell, cloud shell. If I click here, it will open a terminal for me. It will take some time, obviously. And what you can do within this terminal, I would say everything that you would be doing in your local terminal. See, one terminal is open for me. Now I can literally do everything that I need. I can create resources. I can maybe delete the resources. I can upload some files. See, everything is CLI, right? Everything is CLI behind the scenes. Make sense? So we can perform all those things with the Cloud Shell. This is called AWS Cloud Shell. Perfect. Very good. So one is UI or AWS Shell. So we have both the options, but in both the cases, we need to use AWS portal. Make sense? Very good. Now the second way is very interesting. It is called local CLI. Okay. Now what is the difference between local CLI and AWS CLI? There's not major difference. Some people like to use their code editors, for example, VS Code editor, right? Some people prefer developing their code using their own local code editors. So for that particular purpose, you can use local CLI, right? For that, you can download AWS CLI. If you just go to Google, you can easily find it. You can download it. Yes. But personally, I'm not a big fan of using local CLIs, right? Because being a developer, I need to use the local code editor for real development. I don't like to just run those CLI commands, because CLI commands are actually using the REST APIs under the hood. So I like to be closer to the real code as much as I can. That's my personal choice. Like, you can use local CLI because local CLI is quick. You can perform the task in one line, maybe one phrase, but I prefer being closer to the real code. So the third and my way of doing it is SDKs, or SDKs, or you can basically say REST APIs. REST APIs. Because SDK, I should not call it as like SDK, because SDKs are again like built on top of APIs, right? But still you can say SDKs or REST APIs. Make sense? Or I can just say SDK. Perfect. So these are the three ways, and remember this thing, because this can be a very tricky question in your interview as well. The base of everything is REST API. Yes, the fundamental is REST API. SDK is built on top of REST API, because SDK is what? Built-in functions, right? Local CLI is also built on top of REST API. Simple. And obviously portal is built on the backend, right? So let me just write the code for you. The base and the fundamental, the base and the fundamental unit is REST API. Others are just the wrappers built on top of it. SDKs, local CLIs, AWS portal, everything is using REST APIs under the hood. Okay, this is very important. You should know about it. And just to mention one more thing, this will be the case with all the cloud providers as well. So it is not just with AWS. Okay, very good. So now you understood this thing. Oh man, my shake. Okay, so now let's say you are a user. Okay, now this user wants to, let's say Anna. Oh, we forgot about Anna, man. Not a good thing. Let's say this Anna wants to access this bucket that was created long time back, right? And we also uploaded the data as well. Perfect. So now this Anna wants to access this data, but not from the UI, in the local code editor. Let's say VS Code editor. Perfect. Because Anna is on the VS Code editor currently. So how we can just access S3 bucket data in the VS Code editor? Because Anna is doing some development with the pipelines, with something which requires local development with S3, right? Very good. So here Anna has three options, not three, by the way, two: local CLI and REST APIs, right? Or SDK, same thing. So here Anna will utilize SDK, but it is not very simple to use SDKs. Why? You know the answer. The answer is IAM. Here We want to use what? We want to use what? We want to use S3 data, right? S3 data is secured. That means we need to allow Anna to access S3. So what we will do? We will simply say permission or policy. And which policy? S3 full access, right? So we will create one policy called S3 full access, and this Anna will have this policy attached. Perfect. Now this Anna can access this data. Otherwise it is not allowed. Simple. Very, very, very good. This is one thing, by the way, right? And how Anna, like this Anna has the full access, makes sense. How Anna, or basically how S3 knows that Anna is asking me for the data. This is again like security question. Anna has the policy. That makes sense. But how S3 knows that it is the Anna who is asking me for the data? So for that, Anna will show his or her ID card. Yes, that ID card. The same thing that you show in your university or college. That, hey, security guard, please allow me. I am the student of this college. See my ID card. That Ansh Lamba has never showed. Wait, Ansh Lamba, did you get your ID card? See, do not talk about me, because I cannot explain like how was my college life. I don't know like if any of my college friends are watching this video. So I didn't like I was not the person who was carrying ID card and all. Like my face was enough. So yeah. So now Anna will show the ID card. Now how we can just show the ID card? Now we will learn an important concept called access keys. Perfect. Now Anna will also provide its ID card, and that ID card is called access key. Make sense? That access key. So first of all, Anna should have permission. That means Anna should have admission in the university. That's the non-negotiable thing. Once Anna has admission in the university, now the security guard standing here with the stick. So there's a security guard, right? Guard, or let's say security. So security guard is standing here for the passport. ID card. Where is your ID card? Do you have ID card? So this person will say, do you have ID card? If yes, then you are allowed, otherwise no. So Anna will say yes, here is my ID card. Simple. So now let's try to implement it step by step. And now I know this can be a little challenging for the beginners, but just follow me step by step. You will learn everything. And here is my VS Code editor. Even before VS Code editor, you need to do one thing. So let me just go to my AWS. So here, let me first of all close my terminal. Let's go to S3 bucket. And let's first of all create, this is my bucket. If you remember, I need to provide the permission to my user, right? Very good. So now what I will do, I will go to my AWS. I will go to my IAM. That means identity and access management. Good. Here you will see that I have 3 users. Let me click here. So let's go to Anna. So now Anna doesn't have any kind of access key, as you can see, right? See, Anna doesn't have any kind of access key. So now we need to create one access key for Anna, right? So use case local code, you can simply ignore it as well. But let's say I want to local code. It's good to just provide some context. I understand the above recommendation and blah, blah, blah. Very good. Go to next. Description, I don't need to provide it. And now I will click on create access key. Now, obviously this information is sensitive, so I will not expose it, but you can also create access key. So the moment you will click on create access key, it will create 2 options. Oh my God, my lovely mic. So it will create two options, like basically 2 things. One is access key. The second thing is the secret value. One is access key. The second is secret value, right? You need to save both the information in your, let's say, notebook or anywhere, notepad, anywhere. Okay. So let me just quickly do that. So I have created the access key and password, and access key is your access key, and secret access key means the secret value. Simple. So now our access key, our ID card is ready. Now we need to allow the policy, basically provide the policy permission to Anna. So currently Anna has administrator access, which is like more than enough. So we do not need to explicitly provide any access, but usually your user will not have the admin access. So let me just add permission just for your simplicity. By the way, it is not required because Anna has administrator access, but still let me just show you how you can do that, right? So I will say add permission and attach policies, attach policies directly. Open your mouth while speaking, Ansh Lamba. S3 full access. Nice advice. So let me just click on next and let me just click on add permissions. So here, as you can see that I have provided the full access Amazon S3 full access. Perfect. So now our Amazon basically AWS work is done. Now let me just quickly jump on my favorite code editor, VS Code editor. So here in this empty folder, you need to create one .env file, which looks like this. .env. Now what is this .env file? I will tell you. Basically this is used to store the secrets in a better way, and it is a good practice in the development lifecycle. If you do not know about this, you should know about this as well. Perfect. So now what I will do, I will simply create two variables. Okay. The first variable name is AWS access key ID and the second variable is AWS secret access key. Simple. So let's quickly create that. AWS access key ID, and you can just put your value that you have, right? And I will simply say AWS secret access key. That's it. So here you can just put your secret access key, right? And you can save this file. Perfect. And obviously I will just replace this particular file with the real values, and you can also do that. Let me just quickly do that. So I have saved both the values here in the .env file, and now my secrets are there in the file. Perfect. So now let me quickly open the terminal in the VS Code, or you can just create in your particular favorite browser code editor. So here let me firstly quickly create the virtual environment, because I would need to install some libraries and I don't want to install it on my global environment. I will say Python -m VNV and then let's say .vnv. My loyal data family members will say, Ansh Lamba, you always promote UV and now you are using this old method of creating Python virtual environment. See, we are learning AWS, right? So now I will just talk about UV. That will take 10 to 15 minutes. So let's use this old way, but yeah, I love UV. So let me hit enter. Now my .vnv is created. Perfect. And what is this? Python blah blah blah. Yeah, that is fine. Let me first of all quickly activate it, because dot is not recognized command line function. This happens, by the way. So let me just quickly delete this virtual environment and let me just recreate it. That's why I love UV, man. Let me just say Python -m VNV .vnv. Perfect. And let me just check if I have the activate script. Oh, now it is done. See, if you also see the error, just delete and recreate the environment. And let me just check, do I have activate script now? It is in the scripts. Oh yeah, now I have activate. Like earlier I didn't have that script. I don't know like what it does, man. I love UV. So I will simply say .vnv scripts and activate. So this is the command to activate the virtual environment. As you can see, now it is activated. See, can you see this? Oh man, this is so much zoomed in, but it's fine. It will be better for your demonstration. So now what are we trying to do? Let me quickly create the Python file and let me just call it as, let's say, s3.py, right? So now we need to add one you can say package. It's called boto. Pip install boto3 and it will take some time. This is the basically class that we can use to access our all the resources, and we can create a client, because you need a client to talk to the backend, right? So we will create the client. So here you can say import boto3. Perfect. So now after importing this particular thing, now you can simply create a client, right? Now you do not need to remember this code, because all of this code is available in the documentation and they keep on changing the functions. So you can go to the documentation and you can even take help from AI to generate the code, but you do not need to remember this thing, because this is just a client. There is nothing to remember first of all. So first of all, I will say s3.client equals to boto3.client. I also do not remember this thing. I simply get the code from documentation whenever I need, right? So I will simply say s3 client, so boto3.client. So now I will simply say to which service I need to create a client. I want to create a client to S3, like I want to communicate to S3, right? Perfect. Along with this, I also need to provide the very important stuff, which is region. Now how I will get the region? The region name is, I think in my case it is Canada Central. Let me still confirm. If I go to, let's say, my S3 bucket, so you can also go to your S3 bucket and here open this thing, then you can go to properties, and not in the properties, I think it should be in the metadata as well. Do like, wait, to the mention, I would say properties maybe. Let me just check where you can just see, because I just saw that particular thing just 1 minute back. Yeah, it is, see, here in front of my eyes, and I'm just looking here. So this is my region, Canada Central one. You can also see like what's your region, and you can just simply copy it and just paste it here. Simple. Now comes the part of ID card. Now we are simply creating the client for Anna. Now Anna needs to show that, hey, I am Anna who is trying to just create this client. So I'll simply say AWS access key ID equals to something, right? Something. Now how we will just bring the something thing? There's a package that first we need to install. It's called, I think, pip install load .env or load dot something. Pip install load, I think something like this. I don't remember the exact name, but let's still try. Boom. This is the package name. Okay, perfect. So we have this package name. So now I can load that particular, all the variables in the current file, right? So I'll simply say from load underscore .env import load underscore .env, right? And then I can say OS, and then I can say load .env. Perfect. So now what this function does, basically nothing fancy. It will import all of the variables from .env file into my existing file. Perfect. And I can simply create the, you can say, variable directly without even hard coding it. So I will simply say, see, it is already recommending me the code. So the code is like this: os.getEnv. GetEnv means you simply want to fetch some data, and there is one more code that you can use, os.environ.get, and I like this one, so like I like that one, so I will use that one, os.environ.get. that is a good one, and I use dictionary for that. Perfect. So now what will happen, this particular thing, if you do not use the .env file and this package, which is a good practice to do, you have to hard code those values, and you should not hard code those things, right? It is not good. Make sense? Okay, so these parameters are done, and now the last thing is the bracket. Perfect. So now my client is ready. Now let's say you want to fetch some data. Let's say you want to list all the buckets that you have within your S3. Make sense? So let's try to list all the buckets. List all S3 buckets. So I will simply say, let me confirm if this code is right or not. I'll simply say buckets equals S3 client.list bucket, because there's a function called .list buckets, and I can simply run a loop, and I can simply pass this thing. So let me try to run this code, and let's see the errors together if we see any errors. Oh, perfect. It ran fine, man. See, I have this thing, snow bucket Ansh, and this is the creation date, basically the creating date. And if I run it for one more time, you will see the better result. So it is like zoomed in. That is why you're not able to see everything. So let me just run it one more time. And here is the thing. See, bucket name, demo Ansh, snow bucket Ansh, and all of the buckets are here. Make sense? Make sense? And this bucket is also here. So bucket name, bucket name, bucket name, bucket name, creation date, creation date, creation date, creation date. Make sense? This is the output, if you can just see it. I can hide this section as well. Perfect. Now I think you can just see in a better way. So that's how you can just directly talk. So now see, I am into my local machine, right? My local machine has no link with AWS, but still I'm able to talk to the AWS. And you know what? I can even upload the data directly from here. So let's say I just want to upload it. There's a function called, I think, upload or put. I can even copy the data between buckets. There's a function called .copy. So there are like so many functions. So if you just right click on it, S3 client, Boto 3 client. If you click here, you will see all the clients here, and you should see like how you can just pull all of the data. I would recommend to just go to the, you can say SDK. I can just show you. So let's go to the official website. Boto 3 documentation. So AWS SDK for Python. Perfect. So this is the official documentation that you can also follow. Simple. So you can click on any link for the first iteration, quick start. And here you will land on this particular thing, code examples, deliverables, installation. So there's just everything like mentioned, how you can just install, and then using the AWS common routine, CRT, then configuration and everything using Boto 3. See, I have literally performed the similar thing, not exact thing, but yeah, I have performed similar thing. Then you can also see developer guide. Then you can also see the code examples and code references, available services. So all the services are here. Let's say you want to talk to S3, but you do not know about the code, because you are not an astrologer that you will know, hey, oh, okay, what type of function they would have created within that class. I don't know. And how do I know? Did I write those functions? Obviously no. So how do I know? Through the documentation. So you do not need to feel like I don't know how to write the code. You do not need to know. Because I know there's a like common thing nowadays. If you do not have that thing, they simply say, hey, there's nothing like that for data engineers, because data engineers do not need those things. So let me just search S3. So here's S3. If I open this, everything is here. See, if I want to copy, if I want to create, if I want to delete a bucket, if I want to, let's say, put something, everything is here. See, put bucket, list parts, list objects, everything. Wow. If let's say you want to delete a bucket, you can even delete the bucket. Let's try to do that. Let's delete a bucket. So client.delete bucket, bucket name is this, expected bucket owner is this, anything. Bucket name and expected bucket owner is this. Makes sense? And they have even specified that what each parameter should expect. The account ID of the expected bucket owner, who is the owner of that bucket. If the account ID that you provide does not match the actual owner of the bucket, the request fails. Let's try to run this in front of you. Let's have some fun, because that's how you learn and grow, right? So let me just quickly delete a bucket. And I will simply say client, I think it is S3 client. Perfect. Delete a bucket, and bucket name is, let's say I want to create demo Ansh. And owner, they have said that I need to just pass the ID. So in my case, I can use the alias. Okay, let's try to run this, and let me just comment it out, because I don't want to list anything. Perfect. Let's see. Access denied. So that means we need to just pass the right, you can say, access for it. Let me just show you how you can just do that. So here you can simply put your account ID instead of alias, because I thought like it will work with alias, but logically it should not work, because this is just an alias. Like many people can have the same alias. So let me just put my account ID, which is a 12-digit number, which is this one. And now let's try to delete it. And I have just changed the bucket name by why? Because the demo Ansh bucket is not empty, and I just realized it is not empty, and I do not want to delete it. And this is an empty one. So let me just try to delete it. Okay, let's see the output. Okay, the output is none. That means it should have worked. Let me just check. So if I refresh my buckets, and let me just show to you as well. So this is my bucket. Perfect. Earlier I had four buckets, including snow something, whatever the name was. What was the name? Snow bucket Ansh, yeah. So now that bucket is deleted. See, you can perform all the tasks. You just need the permission. You just need to provide the context. Simple, right? And let me just uncomment it as well. And I will just provide this code example as well in my repository. So do not need to worry. This code file will be there. But just make sure that you change these values with your values. Otherwise, it will not work, right? Makes sense, makes sense, makes sense. And the core of this particular execution is that environment file, because that environment file makes sure that you are using all the right credentials, and that's it. This is a quick tutorial and I hope it will be helpful for your data engineering journey and obviously in your interviews. And because see, when you're just showcasing your skills and when you're just saying that I have the real experience, so you need to just talk about these things as well, right? Yes, you can talk about S3 easily. Everyone can talk about S3. But what makes you an outlier is when you just talk about these libraries, classes, Boto 3, and you can just say we can just create a client, because this is a very common practice in day-to-day activity. Make sense? Because you do not need to just perform everything from the portal itself. Let's say you just want to create a script that will delete the data which is not required, and you need to automate the script. So for that, you would need to create a Python file, right? And I know you will create a Lambda function for that. Those who are saying who already know AWS, I know, because the next topic is Lambda function. So even in the Lambda function, you write all of these things. Yes, we do not provide these things there because we are accessing Lambda functions directly from the portal. But yes, you need to know about all of these things. And again, I know you are really excited now to know about, hey, what are Lambda functions? What are Lambda functions? We also want to know. So let's talk about the Lambda functions and let's see. So now let's talk about our Lambda functions. You will love this function, like this service. I also love it because you can literally do so much of stuff with this one. Amazing. If you're coming from Azure background, it is very similar to Azure functions plus logic apps. It is basically the combination of both, right? Not actually logic apps, because logic app is more of a workflow where we have multiple steps, and this is just a function. So I will say it is an alternative to Azure function only. Okay, so AWS Lambda functions. There are so many people in the comment section, they simply write Ansh Lambda. Bro, Ansh Lamba, okay? Ansh Lamba. So, what is AWS Lambda function, bro? Just tell us. Just make us understand this thing. So let me just take you to the documentation because it is very simple. And I don't want to show you something else. It is very simple. Let me just directly show you the documentation. Official documentation. AWS Lambda function. Let's go to this page. What is AWS Lambda? In short, let me just tell you. You can literally run your code without managing the server. This is the entire story. Now you can just read whatever you want to do. So let's read what is written in the documentation. Run code without provisioning or managing the servers. Exactly. This is the entire story of AWS Lambda. That means, let's say you want to write a custom code, Python code, Node.js code, Java code, Scala code, any code. There are like so many servers available. I will show it to you. You can simply write your function. Okay, and you would know that if you want to run any function, basically compile any code, or you can say use any interpreter for the code, you need to install a compiler or interpreter on a machine, and then you run the code on that machine, right? Simple, makes sense, right? But now you do not need to manage the resources. It will simply run everything for you and it will provision the backend. What is the benefit of it? Let's say you do not use AWS Lambda, you create a virtual machine and you run your Python code there. Yeah, simple. But the issue is you are not using the machine all the time. Okay, let me just go to my whiteboard. Let me just make you understand this thing. So Anna, come here. Like stay there, but yeah. Anna wants to run a Python function. Like Anna has Python file, okay, or any kind of Python code. So this Python code needs to run. Make sense? Okay. So now this Anna can run the code in a machine, in a server, basically let's say any computer, any VM. And now you are a master of VM. You know how to create VMs. See, that is called a step-by-step guide, step-by-step approach. You learned how to create VMs. If I would not have shown you the VM tutorial, you would be like, hey, what is a VM? How to create a VM? Now you know the VM. Now you can connect the dots. Dot. Open this mouth. Dot. See, I'm really hungry and I need to eat something, but I don't have anything to cook. So I will say whatever I want to. So this is a VM, okay? Let's say EC2. Anna can run the code on EC2. That's not a big deal. That's one of the options available. And we know that. But if Anna uses this approach, Anna just wants to run Python code, let's say once a day, twice a day, thrice a day, 10 times a day. But what about the other time? Machine will be like in the idle state, wastage of resources. Makes sense? Wastage of resources, and I would say scalability. Sometimes the code requires high compute, sometimes the code requires less compute. Scalability of resources, right? It will take time. It's not a big deal, but it will take time. Scalability. What's wrong with the spelling? Scalability. What? This is a spelling, right? Just ignore it. Scalability. Oh, makes sense. Scalability. Scalability of resources. And there are so many other problems as well. And obviously you need to manage this machine because this is a infrastructure as a code. So you need to manage the infrastructure as well. But now AWS came into the picture and AWS said, bro, why can't you use my service called, by the way, I would have EC2 as well. Yeah. Yeah, makes sense. Let's use this one. Let's use EC2. When we have the icons, we should use this, right? So Anna can use EC2, but now Anna will use Lambda function. Now what are Lambda? Or basically what is Lambda function? Lambda function is a serverless service which will manage the server. Okay, it can auto scale up and down. There will be no wastage of resources. Plus it can run the Python functions on demand as well. Let's say I can just attach a trigger. Don't worry, I will just show you the end-to-end example, end-to-end flow as well. But for now, you can understand that Lambda is a special type of service which can run your code on demand whenever you want. And it will only charge you for the moment or basically for the time frame it is running. Wow. This is amazing. You do not need to upgrade your, you can say, OS. You do not need to upgrade any kind of, you can say, interpreters, compilers. You do not need to even install anything. Everything is there. You just need to click the button, submit your code, and that's it. Boom. This is Lambda. This is a better approach. So I'll simply say serverless. Okay. Serverless, I would say compute, or basically serverless interpreter or compiler. Compiler or interpreter, because in Python we do not use compilers. In Python we do not use compilers, we use interpreters. Interpreters. Okay. Can easily scale up or down. Can be triggered on demand. Perfect. Make sense? So this is a better way to do that. EC2. And we'll say, go with this one, bro. Ta-da-da. Perfect. AWS Lambda. See, I'm not saying that you can literally replace EC2 with Lambda. I'm not saying this thing. There are so many like critical tasks that you have to perform in EC2. I'm not saying that. I am saying when you just need to run the on-demand functions and that's it. Like small functions, and for that why you need to just waste money on EC2. I am talking about that particular development, bro. Make sense? Okay, good. So let me just show you the documentation now. Now I can think you can just understand everything. Run code for virtually any type of application or backend service. Just upload your code as zip file or container image. Oh, you can also upload container image. Yes, if you are familiar with Docker and containerization, you can even upload the container image. And Lambda automatically allocates compute execution power. Wow, it runs your code based on the incoming request or event for any scale of traffic. Write Lambda functions in your favorite language, Node.js, Python, Go, Java, more, anyone. And use both serverless container tools such as AWS SAM or Docker CLI to build, test, and deploy your functions. Amazing. And you can just build web applications around that, machine learning, data processing. There are so many use cases. So many use cases. And yes, we can use AWS Lambda with free tier. That's the best thing. And you know what? I literally love AWS because it provides free account for 6 months. Azure provides free account for 30 days. I don't know about GCP because I don't know like why people use, like GCP is good. GCP is good. GCP is very good. GCP is good for just the storage solution. It has amazing data warehousing tool called Google BigQuery. Amazing. It has amazing storage solution, GCP, amazing. It has very well integrations with all the enterprise solutions, Google Drive and now Gemini, amazing. But from data engineering point of view, from pipelines point of view, from those automations point of view, Azure is the number one, then AWS, and that's it. That's it. Okay, so now let's try to see in our console. So let me just quickly go to AWS and let me show you how Lambda first of all looks like. How does it look like? So I'll simply say Lambda and click here on Lambda. I have created one function, by the way, and let me just create a new function in front of you. Author from scratch, yes. Function name will be Ansh Lambda. Ansh Lamba. Ansh Lambda. Okay, let me just say Lambda Ansh. Okay, now it's good. So now you can just pick the runtime. As you can see that we have option to pick the runtime. I will say Python 3.14. Not at all. 3.14 is just released. There will be like so many bugs. I will say 3.12. Yes, but you can just scroll. There are so many options. See, so many options. So I'll simply say Python 3.12 and x86-64. Perfect. Permissions for now it's fine. And I can also say change default execution role, create a new role with basic Lambda permissions. So now it is very important. So do you know what it will do? It will create a role automatically, because see, Lambda will be talking to some service, and in our example it will talk to S3 bucket. So by definition and by rule, Lambda should have the permission to access S3, right? Very good. You are learning very quickly. So we need that one role, but we need one more role which is called Lambda execute. But you know what? Whenever we create this particular service, it automatically creates a role which simply says that it has the permission to execute the Lambda. So that is why it is saying create a new role with basic Lambda permission. That means you would at least require that basic permissions like execute and all, but you can explicitly provide the permissions as well, right? Very good. So I can simply say this thing and change default execution role, additional configurations. Let me just check this one as well. Oh, this is fine. This is like networking stuff. So let me just say create function. So now it will open the window for me where I will see the embedded code editor within the AWS CLI, not a CLI, basically AWS portal. And then we can literally write any code within that and we can test it as well. Yes, it is amazing. So see, this is your function. Okay, dismiss. And this is the Lambda function. And if you just scroll down, this is your code editor that is embedded. That is embedded within the AWS console. Makes sense? You can literally write anything here. We will write everything. Don't worry. I am simply giving you the quick walkthrough. Makes sense. And here we have all the things written. Makes sense? And now I will just show you one thing. If you just go to, let's say, functions. Okay. And if you just go to Lambda Ansh, you can just go to configurations, right? And in the configuration, you will see that general configuration. Click on edit. So here you can just see like memory, it has like 128 MB memory because it requires like very low memory in the beginning. It can scale up, and you can just say use an existing role, and you can also create a new role as well. So existing role is this one. See, it has created this role for me, service role, Lambda Ansh role, and this. If I just click here, it will just list all of the roles that I have. Currently, I just have these roles, right? And this role is automatically created by the AWS. Make sense? This is the role name. I can literally copy this name, service role, or I can just simply search service role / Lambda Ansh. Then I can go to this specific role and I can add more permission to this role, because by default, this role just have that particular thing, which is called execute something. I will just show you. Let me just take you to the IAM because that is even more important. Otherwise you can see some errors. So I will go to roles, and here we have roles available, but where is service role? Service role for Lambda something. Let me just see. Service role, yeah, Lambda Ansh. If I click here, you will see just one particular policy, which is called AWS Lambda basic execution name. I can add more permissions here, and I should. Make sense? So let's try to add more permissions when we will just performing those things. Currently we are not performing, so we will not add anything. Make sense? So now let me just show you the complete or basically the very first example with Lambda functions. Let's see. So now let's try to create our first Lambda function. Okay, let's do it. So you can just go to your AWS home, and then you can just simply type Lambda. Perfect. And don't worry about any role, any kind of permission. We will assign the permission later on, right? So this is our first function that we created, Lambda Ansh. Let me just open it, because now we want to write our code and we actually want to see what exactly inside this function. Perfect. So this is my Lambda function, which is called Lambda Ansh. Now here, if you are familiar with VS Code editor, right, it is very similar to that. Make sense? Earlier I know the UI was different, but now it is very similar to VS Code, which I appreciate. So now what is the, you can say, high level thing that we should know here? So the thing is, here whatever you write inside the function will be defined for my Lambda Ansh function, this function. Okay, it is a Python function because I have picked the Python interpreter. If you pick Node.js or any other Java, Ruby, whatever, then obviously you need to just use the respective language. So now in this particular file, which is called lambda function.py, we can write literally any code, like we can just type anything here, whatever we want. Make sense? And you know what? I like this feature, by the way. So we can also use something called as code completion by AI, and it is also enabled for this particular, you can say, embedded code editor. That is a good thing. So here, let's start very simple. Let's say you just want to create a kind of very simple function, and this is the function name. You should know about this. This is like Python fundamentals. Then we have two parameters. The first thing is event. This is very important. Context is not very important from development standpoint. Now what is event? Event is nothing but just the input coming from the previous activity. Now you will say, Ansh, Lamba, which previous activity? We just have this function. Yes. So this is just for the testing phase. When you are developing this thing, when this function is ready, you can trigger this function using this button called add trigger. So whatever trigger you will create, there are so many triggers. I will just show you, don't worry. There are so many options. So what will happen? Let's say you pick a trigger for S3, right? So the input of that particular trigger will be passed to the function. Why? To handle the state, so that you can use that information to implement some logic in your function if you want to, right? So here we are not using this event variable here, right? So it's your choice. It's up to the requirements. Context is just like, it will just provide some metadata. It is not super important, but event is very important. Make sense? So let me just show you one thing. Let's say print this event as well. I will say event as event. Make sense? And then it will return the status 200 and body hello from Lambda, blah blah blah. Make sense? So this is our function. Now if we just want to run it, you usually click on the play button. We do not have any play button here. I can simply say deploy. So what will happen? This code will be deployed to this function. Perfect. It is deployed. Now I can test this function because I don't want to trigger it for now. I just want to test it, right? So what will happen when I will say test? So let me just click on test. So it will say create new test event. So currently I do not have any kind of event. right? I do not have any kind of input. What is the event which will trigger this function, which will run this function? So I will simply say create new test event. So here it is saying like which type of event you want to create. I will simply say test event, or let's say test event new if I would have created in the past. So test event new for just for the new name. So invocation type is synchronous. We do not want asynchronous. Event sharing settings private, and this is the input. So that means my event variable will have this particular value. Let me just change it. I will simply say name. Okay, and let's provide the name. Let's say ABC. Let's say email. Let's say abc@gmail.com. Let's say my input is this, right? So what I will do, I will now simply say deploy. Again, no changes, perfect, because we didn't change the code. Let me just say test. And now, is this save? Oh, I didn't click on save. So now let me just close this tab first of all. Now let me say test. Now what will happen, it will run this function and you will see everything in the response. See, response, status code 200, body, hello from Ansh Lamba, and that's it. That's it, because that's what we actually returned, right? That's what we actually returned. Okay, makes sense. Now, I will just show you, you can also monitor this thing. If you just go to, let's say, first of all, let's go to test so that you will cover all the tabs as well. So test is nothing but the same thing that you created in the past. See, now you can just change it as well if you just want to change it. Make sense? Now let me show you the monitor tab. This is very, very important. So in the monitor tab, you will see all the invocations, all the things that you have just done for this particular function. And currently we do not have much thing, but in the real world, you would see a lot of events going on, because whenever we create the serverless function, we call that function from so many APIs, maybe asynchronously as well. So you should know about that thing. Make sense? Okay. So now in the test event, you can also click on CloudWatch. CloudWatch is basically, if you are coming from Azure background, it is very similar to monitor. Simple. Make sense? So here you will see all the, you can say, monitoring if there is any live API calling for this particular Lambda function. Make sense? So there's nothing much in this particular thing, but yeah, you should know about all these three main tabs. Perfect. So now I also want to show you another thing which is important. So if you just go to the monitor tab again, I know like you will use this tab whenever you just want to monitor invocation and all, but there's one more good thing. You can use this tab to have a look at your previous invocations as well. And for that, you can simply click on this CloudWatch logs. And if you just click here, it will just open a new tab. And here you will see all of the invocation. See, for our this function, we just have one invocation, right? This one. Let me just click here. And you will see everything here. So it was invoked as at this time, and this is the request ID. This is the event that we have provided to that function. Makes sense? And everything will be here. See, this was the event. So all the information will be here. Everything. 128 max memory, blah blah blah, everything. Make sense? Okay. So now if you just want to go back, you can just go to the previous tab like this. Perfect. So here in our function, we are simply printing the event as well. So let's now try to create a key value pair for event. Let's say event. Perfect. Just to show you like how this event will look like, but you already know how this event will look like because you saw that particular output, right? Event is something like that. Make sense? So I will simply say deploy. Remember one thing, whenever you just want to save the changes, you have to deploy it because it is a kind of live connection made to the code editor. So that is why. Now let me just say test. Test means basically you are invoking the function. So now you will see the event as well, see in the body. And now if I go to, let's say CloudWatch, if I just click here and if I see, now I have the second invocation as well. If I click on the second one, this is the latest one. Now you will see this is the print statement that I'm printing. See, event is and name ABC email blah blah blah. Make sense? Return statement will be same, exactly same, because return statement is like printed here. So that's how you can just create the functions. Now this was like very basic function, and this was not invoked, you can say, through a trigger. Now what we can do, now we can try writing a function which will actually perform something meaningful. For example, let's say you are building a pipeline. Okay, you are building a pipeline, and in that pipeline you want to basically add a step where this function should run automatically on the basis of a trigger. Now trigger can be anything. If I click on add trigger, you will see a long list of triggers. Select a source. See, it can be an API gateway, it can be IoT, it can be S3, it can be like anything. See, there are so many things that you can just use to trigger this particular function. Okay, so let's take a very simple example. Let's say you want to trigger this function through AWS S3. So let's say if you want to just upload any file to your S3, and then this function should run automatically, because we discussed about this function in the beginning as well, right? So we can do that as well using S3 trigger. Make sense? Got the requirement? Okay, so makes sense. So we will just apply this thing. Okay, very good. Now what I will do, now I will just show you that you can even open this particular thing in VS Code as well. So when you will click on this, obviously I will not do it right now, but if you want to do that, you can. If you click on this thing, it will take you to your VS Code, and there it will ask you to install the AWS extension. It is called AWS Toolbox, or I think Toolkit. You can install it. And what will happen after that? You will be able to write the function in your local code editor, and it will be automatically deployed here because it will be a live connection. But it will throw error in the beginning because you would not have downloaded something called as AWS CLI, right? So it will give you a prompt that, hey, if you just want to download it, you can simply say yes. If it does not give you the prompt, you can simply go to the Google or any browser and simply download the AWS CLI and install it on your system. Then it will work. Because what happens is you will open this code in your VS Code editor. So it simply needs to authenticate you. So it creates a profile, AWS profile in your local system. If you want to do that, you can, but I would say you can simply write the function directly in this particular code editor as well, and it's really good. Makes sense. So now what we are trying to do, we will simply establish something that we have just discussed, that we want to trigger this function on the arrival of a file, right? For that, if you remember, I told you that we will create our own custom role, right? So currently, if I go to functions, this is my function, and if I go to configuration, I will see that what are the permissions and function URL. Like you remember, like we had that particular thing, like where it was written that what role we have assigned to this particular function. So that role was like pre-built role, which is not a very good way to manage the permissions, like according to me. The professional way is you should always create your custom roles, because in your custom role, you can add more and more policies. Now, some people will say, bro, you can also add the policies in those in those roles. Yes, you can. But the thing is, I want to reuse the role in multiple, you can say, instances. Then it doesn't make any sense, right? So I will create my own custom role. Okay. So now if I go to AWS, I will go to IAM, and I will create a new role, which will be like more readable plus more generic. That is not just restricted to only one function. I want to make it available to any, you can say, service. Make sense? So I will simply go to roles, and let me just, so I think it was this one. See, Lambda. Let me just delete this. Let me just copy this. Perfect. Let me just create my own role. So I will simply say create role, and yes, to the service. I want to create it for all the Lambda functions. Perfect. And then next, then I want to give, first of all, Lambda execute. This is basically the permission and all the, you can say, basic permissions that we will allow to this particular Lambda. right? And it also by default adds the permissions such as get and put access to S3. That means it can read the data, it can put the files, but I will also add one more thing, which is S3 full access. Next, so we have two roles, right? These two roles, and let me just simply say create role. Role name will be, let's say, Lambda access S3. Make sense? Lambda access S3. So I will simply say create role. Now this Lambda can access S3 in any way, right? So Lambda access 3, and now we can just go to our Lambda function and we can pick this role. Go to Lambda and Lambda Ansh. Now let's find where we have defined that particular. I think it should be in the test maybe, or in the, most probably it should be in the configuration. So here we have role name. Okay, so this is the role name that we have defined. So let me just click on edit because we want to edit it. Perfect. Existing role, we want to provide this role, Lambda access S3. Perfect. Save. So now what we will do, we will simply say add trigger. Make sense? Add trigger, and trigger will be S3. Perfect. Trigger will be S3, and we need to pick the bucket. I want to pick this bucket that we have created. Perfect. Event types. Event types means whenever someone has added a file, that means put. Put means whenever we just want to create a new file basically, but put means add as well, so it's fine. Make sense? And we can just cross this, just put. Prefix, if we just want to define a specific folder, we can define the prefix, and let's create a new folder called trigger, right? And recursive invocation, if your function writes object to S3 bucket, okay, ensure that you are using S3 buckets for input and output. Writing to the same bucket increase the risk of creating a recursive invocation. Yeah, I have already done that. So what it is saying, usually when we just want to trigger any function, it encourages to write or basically move the data from one bucket to another bucket. It asks you to do not read the data from the same bucket and write the data to the same bucket, because it can create a recursive loop. And I did it. I still remember, like, I received the email, hey, that you have a recursive loop in your AWS account. I was like, what? Then I just figured it out. I was like, oh, okay, makes sense. So I can acknowledge, and then I will simply say add. Perfect. So now my trigger is ready. See, S3. Now what I will do, now I know that this function will be automatically triggered when I will be uploading a file in the trigger folder. Makes sense? But for that, let me just write something meaningful. So here we are simply creating a very, you can say, useless function. Let me just create a function, and what this function will do, this will basically copy the data from one place to another. One place to another. So for that, I will simply say import Boto3, because Boto is the library with which we can just create the client and use the SDK, right? So we do not need to install any Boto3 package because it is already installed on the system. Then I can say def, and let me say mover. Okay. Then I will say context, and this AI recommendation is, so context, and the second one was event. Perfect. I can create this function. Now I can write my code which will simply move the data or move the file from one place to another. Make sense? Simple. So I have just written this code for you, and what this function is doing, it is not doing anything special. And yes, I just use the official documentation, so do not need to worry like how to write this code. Everything is there in the documentation, don't worry. So what we are trying to do, we are simply moving the file from S3 bucket to another folder in the same bucket. Makes sense? Because I don't want to create multiple buckets. So first of all, I created the client, but you will notice that I didn't provide any kind of access key. I didn't provide any kind of secret. There's a reason behind it, because there is no need to specify the key and secret, because we will run this function inside the AWS and it will use the role assigned to it. Makes sense because AWS can identify who is running the code. Simple. Now source key means your file that you are trying to move. Destination is this one. Make sense? Or you can even say, let's say trigger here, because I didn't run this code, I simply wrote it, and let's say destination. Usually we can dynamically import these values using the dictionaries, and you can obviously hard code it as well. So currently obviously I'm not teaching you Python to just show you how to extract the values from the dictionary, so I simply hard coded it because we are learning about Lambda functions. You can literally write any code here. Then I simply use .copy method. Perfect. And then I also deleted the original file so that it does not create the recursive loop. Otherwise it will be like doing all the things. Then return, then 200, and file moved successfully. And don't worry, I will also delete this function after this because we are simply writing the data to the same, you can say, bucket, and it can create a recursive loop. I don't think so it will create, but still, just to be on the safer side, you can also delete it. Let me say deploy. So it is deploying the code. Perfect. Do you want to test it? No, just play with it directly. So what I will do, I will go to S3 to upload the file, and let me just grab the file. Data 1. Yeah, I have this file. Perfect. So I will create a new folder here. Folder name will be trigger. Perfect. And I will create one more folder because I'm not creating the folder in the code using mkdir. So let's create a new folder just to be on the safer side. So this will be your destination. Perfect. And we want to upload the file in the trigger. Perfect. Upload, and this is the file. Perfect. data1.csv. Let's say upload. So I have uploaded the file. So now this should have triggered my function automatically, right? Good. This should have triggered. So now what we will do, we will simply go and check it. Simple. Let's go and check it. Okay, let me go to just Lambda. Let me just go to Lambda function and Lambda Ansh. And in order to test it, like in order to see it, like is it running or not, you can go to monitor, CloudWatch, and let's see if it triggered our Lambda function or not. Oh yeah, I can see this. See, and let me just check if everything is fine. So start request ID, warning, error. Oh, I see. I simply renamed it mover because that's my default behavior to obviously provide some name which is more readable. I didn't realize that I'm simply changing the function name. So let me just change the function name here in the code. So instead of mover, I simply need to say Lambda function. I think it was Lambda handler. I don't know. Let me just check it again. I think it was Lambda handler. Yeah, Lambda handler. Bro, what is this thing? How can you change the code? Okay, deploy. And so this is deployed. Makes sense. And this is the log. Okay, good. So now what I will do, let me first of all duplicate it, and let me just open S3 here. Perfect. Let me just delete this file. Let's upload it for one more time. Let's say upload. Now let's check. Did it trigger the thing or not? Let me just refresh it. Yes, it triggered it. Okay. Start request ID, new events. Let me just resume. Auto retrying. Okay. when calling the header not object, not found. Are you serious? File not found. File not found. Which file are you looking for, bro? Lambda function.py. Oh, I see. One silly mistake. So before just building the function in this particular function, I was just building in my different bucket name, and I just wrote this, and the bucket name is Ansh bucket 2026. Just a silly mistake. Just a silly mistake. So sorry about that. Okay, perfect. Now let's do the same stuff for one more time. What do you want? I can actually replace it as well. It's not a big deal, but let's start fresh. Delete objects. Perfect. Let me just say upload. Load. Now let's see what happened here. So this is the latest one, I guess. Yeah. So this is running in the real time. Okay. Okay. Yeah, I think that worked this time. And as you can see, let me just talk about this as well. This is not super important for you because obviously you will not be paying for this thing, but just talk about it. So as you can see, as I just mentioned that we only pay for the duration we run our function, right? So our function was running for 3000 milliseconds. So it has built for 3300 milliseconds. Anshlama, why 300 milliseconds more? Like obviously start and end time, and then memory size was 128 MB max. So it has also utilized the minimum memory, which is 128 megabyte. So that's how your bill will be calculated, right? Make sense? This is like just a high level overview, like how Lambda functions will be built. Now let's talk about the validation. So if I go to bucket, I should see the data in the destination, and perfect, my data is moved by the function. See, data1.csv. And if I open my trigger folder, it should not have any file because I deleted the file as well. That's how you create Lambda functions in the AWS. And you can also trigger it using any kind of trigger. We used it as a file, okay, like trigger, and you can just use it for any use case. Make sense? So this was all about Lambda function, and don't worry, when you will be just covering Glue, which is the very next service, we will also build like one complete end-to-end pipeline as well, because then you will be able to, or you will be eligible to build the pipelines. Make sense? So I hope it makes sense, and you have covered everything. You have covered CloudWatch, you have covered a kind of mini use case for Lambda functions. Like you just triggered the Lambda function on file upload, you wrote the logic in the Lambda function to copy everything, and you also provided a role so that Lambda can access S3, right? And don't worry, even if I just delete this thing, and obviously I will just delete it very, very soon. You can also delete it, this Lambda function. I will just provide this source code in my GitHub repo, so you do not need to worry at all. Okay, very good. So now let's talk about our very next service in AWS, which is called Glue. Glue. And I think you would have heard about this particular service if you are a data engineer. I hope so. So let's talk about Glue. What is this and why do we just use it? AWS Glue. As the name suggests, it is actually used to bind multiple things. Glue is just glue, right? Favicol. Have you used Favicol? Favicol, I think, is an international brand. So if you are from any country, you would have used it, because in India, Favicol is very famous. I don't know, like if Favicol is available outside. I don't know. So if you didn't understand the context, Favicol is like a very popular brand for glue. Okay. So now AWS Glue. AWS Glue, as I just mentioned, that it is a kind of solution which is made to bind multiple components for a solution. Because whenever we build the real world solution, whenever you just build the end-to-end data engineering solution, It's not like we just want to do one thing. Data engineers do multiple things together, and at the end we bind it with a glue. Make sense? So for example, you have multiple things. Multiple things means, let's say you are doing one thing, let's say you are extracting the data from the source. Let me just try to draw it so that you can just understand. So let's say you have some data coming from source, right? You are fetching the data basically. Okay. And then let's say you are applying some transformation, some Spark notebooks, anything, right? Let's say you are just writing some Spark notebooks. And then let's say you are also doing some kind of data warehousing, right? Let's say data warehousing. And then you are doing so many things, right? So at the end, let's say analytics, reporting, and you can just build your report anywhere in the Power BI, Tableau, QuickSight, wherever. So this is the end-to-end kind of data engineering solution, right? So now just tell me one thing. Yes, each component, each, you can say, piece of this solution is built differently, right? Each piece is isolated from the other, but just tell me one thing, that when this piece was built, after building or completing the piece, we also need to bind them together to define the dependency. Like, what do I mean by dependency? That means I want to say that I cannot build reports, or basically this report step, directly after the data extraction. No, I cannot do that. Why? Because there's a specific order. First I need to extract, then I just need to transform, then I need to load, and then I just need to report. So AWS Glue takes care of all the dependencies and all of the orders that I or let's say you need to maintain in your solution. So that is why it is also called as ETL solution, because see, this is, let's say, extraction, right? And then this is, let's say, transformation, and this is, let's say, loading. Make sense? And then you have representation layer, which is the reports part. I hope it makes sense. ETL. Perfect. So that is why it is also popularly known as ETL tool. Okay. Because it can perform extraction, it can perform transformation, it can perform loading as well. Everything. ETL/ELT, same thing. Just the way of you can say transforming the data. If you are dealing with small data, you can simply extract and transform right away. But usually we just perform ELTL, that means extract, load, and then transform and then load. It is never ELT, it is ELTL, because you have to load the data back again. It is not like transform the data and done. So now Glue is a solution. Okay. And you know what? The best part about Glue is low no code solution. Wow. Yes, this is the best part. Low no code solution. So that means even if you do not know how to perform transformations using Apache Spark, right? If you do not know how to transform the data, you can use AWS built-in low no code solution to build the entire pipeline. And I will just show you, don't worry, hold your emotions. And AWS Glue has basically two components. The first component is not data lake. I'm just copying this thing just to write it. So the first component is data catalog. Okay, data catalog. So now in data catalog, do you know what? In data catalog, you register the tables. Okay. So for example, let's say you have some data sitting in S3. Okay. Makes sense, because S3 is a source solution, right? So you will have your data in S3. Makes sense. So you have your data in the S3. So now what will happen? You will use AWS Glue, okay, specifically crawler. Don't worry, I'll just talk about it. So now this is a component. This is basically the part of data catalog. Okay, crawler. So you will use crawler to build the tables, to build the catalog basically. Make sense? So this will build the table. Oh, okay. Catalog tables. Make sense? So this is the flow. So you have your data in the S3. Crawler will go to your S3 bucket. Make sense? Crawler will go to your S3 bucket, or basically S3 will be accessed by crawler. Crawler will automatically, let me write it for you. Crawler will automatically fetch the metadata. Okay, you know the metadata, right? The information, column names, table names, you can say data types as well. It can just predict, not predict, it can infer the data types as well. So it will fetch the metadata of all the files / folders, right? All the files, folders, or let's say files inside the folders, files. Yes, it can hierarchically read the data, files or files inside the folders. Okay, and can register them in the catalog automatically. Yes, this is very powerful tool, very powerful. Make sense? And don't worry, we will just see everything that we are just discussing right now. I'm just giving you high level overview. Okay, perfect. Make sense? So this is the role of crawler, if you didn't know about it. So now what will happen? Let's say you have created the data in the S3. Why do you need to register the data in the tables? This can be a very good question. Why? Because see, you have the data in the S3, right? In the data lake, you have CSV files, you have, let's say, Parquet files, you have any files. Now, why are you dumping or basically saving the data in S3? For big data analytics, right? If someone wants to, let's say, analyze the data, if someone wants to query the data. So in those particular things, you need to register, right? You need to register the tables in the catalog. Okay. You need to register those tables, right? Now the thing is, if you want to register the tables, there are two options. The first one is catalog. It will automatically go, or not catalog, crawler. It will automatically go to each file, each folder, all the subfolders, and it will register all the tables automatically. This is the first option. The second option is manually creating the tables. Okay. You can manually create the tables, right? So now what we are just trying to do, first of all, we are learning about Glue, right? So we will use crawler to create the tables, right? Yes, we will also see how we can manually create the tables if you want to do that, right? Okay, and we will learn that thing in the next service. Do not worry about that for now. So for now, we will use crawler, but our agenda is same. We want to register the data in the catalog, and that's it, so that we can use the SQL to query the data, right? This is one component of data, like this Glue. Now the second component is ETL, or let's say visual ETL. Low no code that I was just talking about, visual ETL. This can just perform the entire pipeline using low no code. So let's say you are a user, and this user can use low no code with Glue to build the pipeline, right? So this user can build the pipeline. So let's say any flow, not just pipeline, and like any workflow, let's say like this, anything. Make sense? Perfect. It can build it using Glue, low no code, without any kind of code. Perfect. So this is the high level picture of AWS Glue, Yes, this is very important. One of the most important, you can say, service available in AWS for data engineers. I would even say that AWS Glue is such an in-depth topic that it would need an entire video in itself. But yes, we are covering the fundamentals, so you will gain some fundamental knowledge around AWS Glue. But yes, according to me, there should be a dedicated video on AWS Glue. Makes sense? But yes, we will just learn the fundamentals because we are focusing on the fundamentals in this video. So perfect. So let me just go to my AWS console and let me just search AWS Glue. Perfect. Click here and here you will see all of these things. So this is Glue. Glue is not something that you just create and just you deploy like Lambda function, like S3 bucket. You do not need to create Glue. Glue is the component that you use. Are you getting my point? Glue is the component. Okay, and you just maintain the catalog within that. So if you just see the left hand side, you will see the data catalog, right? If I expand it, I will see the databases. Obviously in the catalog you will see database, tables and all those things. So let me click on databases and here you will see all the databases that you would have. Now in your case it will be empty, so we can create the database inside the Glue. But Glue is not something that you create. AWS Glue is like kind of component, is the layer that you use and you create objects within Glue, right? So let me just quickly create a database and let me say DB, perfect, and create database, perfect. So DB is created, makes sense. Now in the tables, obviously we do not have any table inside DB, but obviously we'll be creating the tables, makes sense. Let me show you. If I click here in the DB, you will see 0 tables. Now there are two options: add tables using crawler, as I just mentioned, and add table manually. And if I say add table, I will see table name, let's say demo table, and database is DB, and then I can say select the data type of source S3, data location is specified in my account, and then data format is, let's say, CSV. And then there are like so many steps, like choose or define schema. If I just say next, you will see it. So include path, I can also define the path. So let me just say browse, bucket and raw. Let's say I want to create table for this. Choose, right? This field is required. Which field is required? It is done, bro. Is required, for example, S3 bucket. Oh yeah, makes sense. So I can simply say browse, this one, and then simply raw, because we define the folder level location. Then say next. So now here, if I just want to define the schema, now I need to define the schema manually. See, define or upload schema. So edit schema as JSON, or I can even add it. So I will simply say edit schema as JSON, and now I can define the schema in the JSON format, like key value, key value, key value. Key is the column name, value is the data type, right? Or I can even upload the file if I have it. But here I am just defining everything on my own, and then it will create the table. This is not a very good thing, because in the real world you get 50 columns, 60 columns, 100 columns, and you can even make a mistake. Let's say you just missed one alphabet. So it's not actually big, like a good practice. So what you can do, I will simply say cancel and confirm. I will build tables using crawler, but you can click here as well, or you can just collapse this particular drop down, and you will see in the same drop down, it's called crawlers. See, just click here on the crawlers, and I was just creating crawler like few days back just to test something, because this was a new account, bro. So I had to just test so many things. So because obviously whenever you just create a new cloud account, even if you have like the older one, still you just need to test all the things, like everything is running fine, because in the previous, all the older accounts, you just define so many permissions, right? And here it is like the latest or new account, so you need to just make sure like all the permissions are there. So I'll simply say create crawler. Okay, or I can just use this one as well, but let me just create a new crawler from scratch. So it will be like demo crawler. Okay, now let's say next, data source configuration, and I will simply say not yet, but you can do that as well. Is your data already mapped to Glue tables? No, so it is not mapped for now. So what is the difference between no and yes? So what will happen if you already have if you already have data source mapped to the tables, it will simply perform the schema evolution as well. So now it is saying data source. So let me just add a data source. I will simply say S3, optional, location yes, let me say browse, and demo Ansh, not demo Ansh, bucket, then raw, and then choose. Perfect. Perfect. And now you can see crawl all subfolders, crawl new subfolders only, crawl based on events. I will simply say crawl all the subfolders, and whenever you see a new file within any folder, within subfolder, create all the tables for me. Okay, I will simply say add S3 as source. Perfect. Now let's say next. Then IAM role. This is very important. Now this, see, now you are well versed with all the IAM things. Now you can just manage these things. And you know what? Beginners feel stuck whenever they just see IAM and they feel afraid. That is why I discussed IAM in so much detail, so that you can just feel happy whenever you see IAM. Now, do you know what it is like trying to ask? It is just asking for the IAM role. Now you already know the answer. We need to communicate with S3, right? To read the data. So AWS Glue should have access to S3. Make sense? So now here I will create a new IAM role. So I can simply go to, let's say, duplicate it, and let me just go to IAM, and I will create a new role, right? I will simply say create role, services Glue. Perfect. And then I will provide the permission called Glue execute. Do we have Glue execute? AWS Glue. Yeah, let me just provide this AWS Glue console full access. By the way, it is not required, but let's say what do we have in Glue? Glue console full access. Yeah, I think this is fine. And now I'll simply say S3 full access. Perfect. Now let me say next and create role. Role name is Glue access S3. Perfect. What is this? Oh, it already exists. Okay, so access S3 new. I would have created it before, so perfect. So now let me just provide this role, Glue access S3. Let me refresh. So this is the one. Perfect. Make sense? Use lake formation. No, it's fine. So let's say next and set output and scheduling. So target database will be our new database, DemoDB, and table name. Okay, so now we also need to provide table name, but we will just allow crawler to define the table name for us as well. And crawler schedule on demand, because I don't want to schedule it because it is costly. Okay, because it just crawls everything. Next, review and create crawler. So now if I just go to crawler, you will see that this crawler is succeeded, right? If I just click here in the crawler and if I say run crawler, so now this crawler is running. If I just show you, see, now it is running. So now what this crawler will do, it will automatically register my table in the database, and you will see it very soon. It takes, I think, just a few seconds, and boom. Oh, which crawler I ran? Oh, I just ran crawler test. Okay, let me just run this one. So by mistake, I just ran this one. Run crawler. Okay, so now both are running, but it's fine, because crawler test is not for our DB. Okay, so whatever it will do, it is just for different DB. It's fine. So now let's wait, and once we have the data registered, and then I will just show you how you can just build ETL solutions, and then we will also build like end-to-end flow for our you can say pipeline. Make sense? Like we will also perform a kind of copy operation with some basic ETL. So okay, this is completed. Crawler test. So this is still running. This will take just a few seconds. Okay, and in the meantime I can see my list, whatever I need to teach in Glue, so that I do not miss that thing. Okay. Okay, makes sense. So this is done. As you can see, stopping. That means it is succeeded, I guess. I think so. So let me just test it. I will go to databases, and I will go to this database, and this raw table is created for me. Wow, automatically. If I click on this table, you will see everything. See the exact schema that I was expecting. Perfect. And I didn't define anything. Crawler did it like did everything for me. And I can even edit the schema if I want to. If I just click here, edit schema as JSON. So see, name is the column name, type is the data type, right? So if you are, let's say, not satisfied with the data type, let's say you want to convert this item into integer, whatever, right? Quantity to string sometimes, right? So you can just change it as well, and you can just then save it, and that's it. Make sense? So this is our table. Now our table is created. Makes sense? That means that we have just learned how to use data catalog. Now you will say, Ansh, Lamba, you were saying that we will query this data. Yes, you will, but not now, in the next service, right? It is just this particular section is just for the crawlers, and you will learn crawlers, and very good. Makes sense? We will just learn querying and all the things in the very next service, which is called Athena. Okay, so for now, focus on AWS Glue because only one part is covered. So let me just cover the other one. So if I just click on this drop down and then click on data integration and ETL, here you will find it's called Visual ETL. And they have also added something known as zero ETL integration. It is just like kind of CDC connections that are built so that you do not need to write any ETL. It will directly map the data with the source, and you will see the changes right away. So just forget about it. Let me just click on Visual ETL because there are three things. There are two things, Visual ETL and notebooks, but we will use Visual ETL. So here you can see that we have create job through Visual ETL, notebook, and script editor. So that means there are three ways: Visual ETL, notebook, and script editor. Make sense? Let me just click here Visual ETL because we are more interested in low no code solution. And by the way, do you know what? Nowadays I can see that industries are like moving more towards low no code solution because they are easy to manage and easy to scale. Plus earlier they used to do a lot of in-house development. Now what is in-house development? That means they used to hire people to build those things, and those people used to stay in the company so that if anything wrong happens, they will be there to fix it because they built it. And whoever has built anything, the person knows the best, right, about that solution. Now what is happening? More and more vendors are coming into the picture. Every organization is not doing actually the in-house development. They are simply hiring the vendors, any vendor, right? And they are building the solutions for them. And what happens after the development is completed? They simply leave the project, right? That's how this cycle works. So who is managing the solution? The people inside the company. The people inside the company have zero knowledge about the solution, have zero knowledge about the design, have zero knowledge. I'm not saying like they have zero skills. I'm not saying that they have zero skills in architecture and design. No, they have zero knowledge about that solution, right? About that solution. Make sense? Make sense? Do you know what? Like why it is a problem? See, let's say there's a chef, right? In a restaurant, and the chef made the dish for, let's say, 100 people. And they enjoyed the dish. Now their relatives also entered the restaurant. Let's say 20 more relatives entered the restaurant, or you can say came to the restaurant. Now they are saying we also want to have the same dish, right? Who will cook that dish? Who? That chef is just gone. You cannot serve the same thing. So whenever you just want to do this kind of thing, if you are doing, let's say, low no code thing, it's very easy. A very good example of this, let me just use the same analogy of like food chain. So I just talked about a restaurant, right? Where you just do everything in a customized way. Everything. You can use any amount of salt, any amount of this, like everything on your own. But just look at food chains like Domino's, McDonald's, or any food chain that you like. I'm not saying that 100% they are 100% same, but they are 99% same in all of the locations. Why and how? Because they use templates. They are given with some instruction that you just want to add this ingredient this much, this ingredient this much, and just cook it for this and this much. Anyone who knows how to cook can follow the instructions and can do the work. So that's the difference. When you use low no code solutions, you have templates built in front of your eyes. You do not need to make everything from scratch. So that is the difference. And I support this thing. Like this is a better way. This is a better way to just manage the solutions because you need to see the things through the bigger lens when you are owning the solution, not just you when you are developing the solution. Make sense? Okay. Enough philosophy is given. Now, Ansh, Lamba, build the solution. Okay. So this is our, by the way, very first ETL pipeline in AWS Glue. First of all, let me just rename it. I will simply say demo pipeline. Perfect. So this is our canvas, as you can see, and we can just draw anything that we want here. Anything means pipeline. So I will click on plus. Nodes. What is node? Node is the activity. Each node is an activity. That means you want to extract the data. So extract data is one node. You want to transform the data. Transform data is second node, then third node, then fourth node, like this. Let me just click on plus button and let me first of all add the data from Amazon S3, right? Because see, now this is our S3. Perfect. So now the use case is very simple. We have the data in the CSV format sitting in the folder, and the folder is raw, right? Raw. I want to process this data, right, in the folder called processed. And the main thing, I also want to apply some transformations, very basic transformations. And I also want to save the data in the delta format. That means in the lakehouse solution. Oh, do not worry. It sounds like a complex solution. For a beginner, it's very easy. Just follow me. So this is Amazon S3. Just click on this node to configure it. So I will simply say Amazon S3 source, because I just want to provide this name. What is this? Will be displayed job as, oh yeah, we know that. We need to just save this job. That is fine. And S3 location, perfect. Let me just browse it and I will simply say raw. Perfect. And data format. Data format is, obviously we know that it's in the CSV format. Perfect. And escape character, it's fine, optional, because we use escape characters when we have, let's say, special characters within the double quotes. When we are using double quotes within double quotes, so we need to use like backslash or something like that. But we do not have that. So it is fine. So this is done. Let me say save. 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 Okay, let me click here. Perfect. So now this is my very first activity, by the way, and it takes some time to remove this thing. So this is my very first node, right? Now I just want to perform some transformation. Transformation can be anything. There is no limit to perform transformation. It can be removing duplicates, it can be removing nulls, it can be just choosing some columns, it can be aggregation, it can be window function, it can be rank, everything, bro. Like everything is a transformation. But in our case, we are not mastering the transformations. We are just looking at some, you can say, basic use cases of AWS Glue and applying some basic transformation. So I'll simply say add node, or basically click on this as well. And now, wait. If I click here, I see IAM role, right? Here you will define the IAM role that AWS Glue can access the S3 bucket. So see, it is asking that, hey, you want me to read the data from S3, but where is the permission? So here is the permission. And the permission is this one. It is very small. If you can see AWS S3 S new. So I will simply provide this thing. And I can also say start session, because if I just want to see the output of the data, I can simply write this, right? Data preview means when you just want to see the data in the live mode, whatever transformations are you applying, because when you just transform the data, you want to see the output, right? It's common sense. So that's why it just starts a session, and it, I think, runs Spark under the hood, because it is very similar to Azure data flow, not Gen 2, Gen 1, where we just simply build the data flow and we can see the output, and data preview, it behaves exactly the same. So if you are coming from Azure background, you can just relate this thing with that. Makes sense? So let me just say plus node, and I want to perform a simple transformation called select statement, because I don't want to select all the columns. I want to select specific columns. Okay. And as you can see, I have second node selected here. If I click here, I can just select all of the columns. So I will simply say parent node is S3 source. That is fine. That means you can define the dependency as per your requirement, but by default it is fine because it is directly connected to this one. Perfect. So let's say I do not want to pick the order date. I want to, let's say I do not want to pick it. I want to pick all the other columns, right? Same thing. Okay. So I will simply say save. So this is done. This is done. And I can also see that the data preview for this thing is this, and it is accurate. We all know that order ID, customer, item, quantity, price, and order date. And if I see the output of this thing, I should not see that column, which is order date, right? And let's see output schema, data preview, ready, refresh. So let's say fields and pick order date. and let me just say save. Perfect. So let me now say refresh. So now let me just add the next node and just click on plus, and this node will be destination something S3, Amazon S3. Perfect. And here, as you can see, oh, I just added the node here, so let me just delete it. Perfect. So let's say plus, and here we do not want to transform anything, we just want to add the target. So target will be Amazon S3, right? But I have two options for Amazon S3. I have Amazon S3 alone, and I have Amazon S3 data catalog as well. Do you know what is the difference? If I only pick Amazon S3, it will dump the data into the folder and that's it. But if I pick data catalog, AWS S3, like AWS Glue data catalog, it will, yes, obviously dump the data, but it will register the data in the data catalog as well. Make sense? But don't worry, we just want to process data because we will use Athena to register the data on our own. Make sense? And there are so many options. You can also pick AWS Snowflake. You can also pick Google BigQuery. You can just pick anything. Make sense? Okay, very good. We rarely use AWS catalog because it's not very good, because usually whoever is using AWS tech stack, they use either BigQuery or Snowflake. Yeah. So perfect. I will just pick Amazon S3 targets, and as you can see that it has created a new node. So now I can click on this node. I can say parent node. Parent node should be this one, right? After select field. So now you will see it has appeared here. Perfect. I will say S3 sync. Makes sense? Sync means like destination. And the format, I don't want Parquet format, I want Delta Lake format because I want to create a lake house, right? Okay. Now I just want to pick the target location, right? I want to just, let's say, let me just create a new folder so that, yeah, do we have in the destination? Yeah, let me just create a new folder. I will simply go to S3 quickly because I want to create a folder called processed. Okay. Perfect. Because otherwise it will simply dump the data and it will not create the folder. So let me just say browse processed. Makes sense? I think even if I do not specify this, like it will create the folder, but it's always good to just create folder beforehand. But obviously even if you do not have that folder, it will create the folder for you. Then do not update the data catalog, obviously. And perfect. Let me just say save. So this pipeline is there. Perfect. Makes sense. Target node not supported. You have selected a data target node which is not supported for the data preview. Yeah, we obviously know. And we don't want to see the data. So this is the pipeline that we have created. Makes sense? Not very like complex pipeline, very simple ETL. We extracted the data, transform data, loading the data. But you know what? I can run the data, like basically run this pipeline, and it will simply run this pipeline. Make sense? Then if I just open the script, I will see the entire script written for me. Because see, all of this drag and drop is what? Is the code behind the scenes, right? See, we can literally, if let's say you do not want to use the visual, you can create the script as well to generate this particular, you can say, this pipeline. Wow. Yes. You can generate this. This is amazing. This is amazing. So if someone asks you, hey, I want to create a pipeline, but I don't want to use a drag and drop feature, how can I just create that? You can just create a script like this, and you have AWS Glue class that you can just use. Makes sense? Now we have job details, all the things, IAM role, everything. You can even change it. Then Python 3, and then worker type, everything. Then you have runs. So we do not have any kind of runs, so that is why it is null. Data quality, if you just see any kind of, you can say, errors related to data quality, you can just measure this thing in this tab. Then you have schedules. If you just want to, let's say, schedule this pipeline, and obviously in the production we schedule a pipeline, we do not like trigger it manually, but this is not a production environment, we are simply learning it, so we will not schedule anything, right? Version control, this is very important. If let's say you want to enable Git or any kind of, you can say, software version control, Git is the most popular one, and 99.99% uses Git. I'm not saying GitHub. GitHub is the software, like is the, you can say, service provider of Git. Git is the real technology, right, for version control. So you can either use GitHub, you can use Azure DevOps, you can use their, like I have seen like a lot of companies use their own service providers as well, built on top of Git. So you can just pick anything. GitLab is also like another one, Bitbucket. So you can just connect to anything. Make sense? Perfect. So now let me just quickly run this pipeline just to make sure like everything is running fine, and then we can just build our end-to-end pipeline including Lambda function as well. Okay, let me just say run, and successfully started the job. And yeah, so it will take, I think, at least 2 minutes, and we can obviously see the preview here as well in the bucket and in the select field. And by the way, in the bucket you can just add one thing if you are just using transformations, which is this infer schema, right? But I just wanted to show you without that as well. Like if you do not use infer schema, it still works, like it runs, but it can fail because it will simply say I do not have the columns. So what happens is, when you just create the transformation layer, you need to make sure that you are also inferring the schema, because then only it can perform the transformations on the top of the column names. So you can enable it, but for now we didn't enable it, so we simply ran it. I just wanted to show you that failure thing. And once you see that, then I can simply say infer schema, and then it will simply infer the schema, and then it will carry forward that schema to all the subsequent steps. Okay, but let's still see. So if you just want to monitor your pipeline, you can simply go to job runs, and there you will see all of the things. You can just ignore these three. I was just testing this thing before showing you this error. So first of all, I did like intentionally failed this, and then I just succeeded it, and now I'm just running this latest version. So let's see, it will take like at least 2 minutes. Okay, so as you can see, this has failed, and I know the issue, but I have already told you that what can be the issue, because when we are just like developing something, we just ignore this thing, but it is very important. So that's why, remember when I just showed you the preview for this data, this was empty. I was like, I will just show you later on, because I knew like this is a very common thing, and when you see the error, you remember the thing. So let me just click on infer schema. So what will happen now in the infer schema? So now it can infer the schema. So now it will pass on the schema to the subsequent steps. Now if I just click on select fields, like select all the fields, now it should give me the output like this. Simple. Now I can simply save it. Now if I just click on run button, it should run fine. Okay, let's see. If I go to runs, and let's wait for 2 more minutes. So now as you can see that the pipeline is succeeded, that means it ran fine, and we can like obviously confirm it before like building the final pipeline. So if I just go to processed folder, I should see the delta perfect. This is my data, as you can see, delta log perfect. So that means our pipeline is running fine and we are good to go. So now do you know what are we just trying to do? Now we are going to just build a complete pipeline, which will be a kind of mini, you can say, use case, because once you know this, you can just implement so many real-time solutions. So what I'm trying to do, we will build a solution where, let's say this is the user. Okay, this user will dump the data in AWS S3. Make sense? A file, and it can be any file. Let's say a CSV file. Simple. Okay, makes sense. Okay, perfect. This will upload this data, right? So now once this data is uploaded, okay, once this data is uploaded, now this thing, this CSV file will be attached here. Okay, now we need to trigger Lambda function. Make sense? We need to trigger Lambda function. Now Ansh, Lamba, why do we need to trigger Lambda function? Let me just tell you. So this Lambda function will have a code. Okay, will have a code to trigger our pipeline. What pipeline? This pipeline that we built, this ETL pipeline, right? Let's say this ETL pipeline. Okay, so we want to trigger this thing, or you can say here we have just S3, so I can copy here S3. Make sense? So this is a complete ETL pipeline, and we will trigger this pipeline with the help of this Lambda function. Can we do that? Yes, we can do that. We can do anything. So this will be triggered inside the code. So we will write the custom code within the Lambda function. We will create a client with AWS Glue, and we will trigger the pipeline directly from the Lambda function. It will be fun. Okay. So let's try to implement this step by step, and you will learn a lot of things with this, and let's do it. So first of all, let's create a new Lambda function, right? Let me just create new Lambda. This is hanged or what? Okay, this is nice. Okay, so now let me just click here, and if I check the Lambda, let's create a new Lambda function, and I will call it as trigger Lambda, right? Trigger Lambda, and this will be my Python 3.12. Perfect. And here, as you can see, change default execution rule. I want to use an existing one. Okay. And do you know what? I will use the existing one, Lambda access S3. But here, if you see the architecture of our pipeline, we are basically triggering the pipeline from the Lambda. So that means obviously Lambda would need S3 access because it will listen to the S3 transactions. But at the same time, our Lambda would need access to the AWS Glue as well, because it will trigger the AWS Glue pipeline, right? So it needs that access. Good. So what I will do now, I will simply go to my IAM role, and let me quickly add that permission as well to that role. So role is Lambda access S3, and let me just add this particular permission. I have already added it, but I'm simply telling you again, which is called Lambda Glue console access, right? Go to add permission and simply add this role, basically policy Glue. Okay, and it is already added. That's why it is not coming here. Makes sense? So simply add this role as well. So in total, it has 3 accesses: S3 full access, Glue access, and Lambda execute, which is like non-negotiable. Perfect. So now what I will do, I will assign this role. Perfect. And then I will say create function. Very good. Now I need to write the code to build that logic, right? Basically, we need to build the client. Again, you do not need to remember this code. First of all, that is the good thing. You can go to AWS SDK and you can find it. I will simply say AWS Python SDK, right? And I can just simply search it. Not this one, this one. So here I will simply go to the service called Glue. Here it is. Perfect. So now I just need to find a function which is similar to run, job run, something like that, right? So I'll simply say start something. Start. So start, yeah, here, see, start job run. So this is the function. So I just need to use this function to call my pipeline, right? So this is the function, and let me just create the client as well. So I will simply go to my Lambda, which is here, and I will simply say import Boto3. Perfect. And here I will say Glue client. The same way we created the S3 client, we need to create the Glue client, and it will look like Boto3.client Glue. Instead of S3, it will be Glue. And then I can say Glue client dot start job run. Job name is demo pipeline, right? Perfect. This is the code. Simple. And then we can simply return if you want to return. Return, let's say, status code, and I will say pipeline triggered. Make sense? Perfect. Pipeline triggered. I can say deploy. Perfect. This is now updating the trigger. So this trigger is created. Basically this Lambda function is created, and now we can just quickly test it by click here on test, and let's see the response. I think it can just ask you to define some demo test. You can simply put anything because actually we are not using any kind of event here, right? So you can just define anything like the default one as well. So I can see that response is null, status succeeded. That means it has succeeded. Basically it has successfully run our pipeline. So I can just check, and now if you just want to automate completely, you can simply say add trigger, and now you already know how to create the trigger, right? Go to here and then S3 and Just do the same stuff that we have done already in the Lambda function section, right? So you can just do that as well. So if I just go to, let's say, pipeline. So if I just go to Glue, I think it should trigger my pipeline, and I can confirm here. If I go to Visual ETL, perfect. So here is my pipeline, demo pipeline, and here if I go to runs, okay, this is running, makes sense. So it has successfully triggered our pipeline. So now it will simply complete this pipeline, makes sense. So that means our end-to-end example, and obviously it only succeeded because we have already tested it. So our main test was triggering this pipeline through Lambda function, creating a client. So we have successfully built this particular logic as well, and now you know how to just work with AWS Glue in detail. Very, very, very well done. Now let's try to talk about a very, very, very important, and yes, the last service of today's lecture. It is called AWS Athena. What is AWS Athena? Let's talk about it in detail. So now let's talk about the Athena. What is AWS Athena? So first of all, for all the Azure lovers, if you are coming from Azure background, so it is very similar to Serverless SQL pool. It is very, very, very similar to that. So basically, let's say you have built your data, you have dumped the data, you have transformed the data, you have even registered some tables in the data catalog. But now it's time to query the data, right? How can you query the data? That is one of the most important pillars of data engineering solution, right? You need to enable the querying as well. Remember, we created some data catalog tables, but we didn't query it because we didn't have Athena at that time. Now we will create Athena as well, because now you need to know how to query the data as well. Make sense? Okay. So now what we can do, I will first of all show you the documentation as we see for all the services. So let's do it for this as well. AWS Athena, perfect. Interactive Serverless SQL query service. I told you it is very similar to Azure Serverless SQL pool. It is exactly the same thing in AWS Serverless SQL pool or SQL query. So what is, or basically why Amazon Athena? Amazon Athena is an interactive SQL query service that simplifies data analysis in S3 using standard SQL. That means you have your data sitting in the catalog, right? It can create external table on top of it. Let me just show you. Amazon SageMaker, no, we don't need to worry about SageMaker. So let me just show you. So let's say you have the data in the AWS S3, right? And you have data maybe in the form of CSV, right? It can be in the form of Parquet. It can be, right? Let's say Parquet. It can be in the form of JSON. It can be, right? Perfect. This is JavaScript, but yeah, let's say JSON. So all of this data is here in the S3 bucket. Make sense? Right? Simple thing. Okay. Now this is our data repository where we have all the data. But just tell me one thing. Let's say there's a user who wants to query this data. So how this person can query the data? How? Using Athena. Okay. Using Athena. So what Athena will do? Athena will say, bro, you do not need to worry about anything. You can just use my data catalog. So Athena will come into the picture. This is basically the abstraction layer built on top of S3. Okay. So you will not query S3. You will query Athena. Okay. And Athena will automatically query this thing. Let's say like this. Make sense? Abstraction layer. Okay. So it will act as an abstraction layer. Which allows you to build SQL queries and run against it. Make sense? So you do not query directly the S3 data, because let's just tell me one thing, that you have this data, right? So now you want to obviously use this data. So you cannot query this data directly because this is like unstructured data, semi-structured data, and you cannot use SQL on top of it. So if you want to use SQL engine, SQL queries, you will perform your SQL queries on top of Athena, and Athena will build the abstraction layer on top of these files so that you can run your SQL queries to analyze, to do whatever you want. Simple. This is Athena in a nutshell. Now let's try to see how we can just work with Athena. Simple. Let me just pull my AWS screen. Perfect. So now let me just say Athena, and this is our Athena, and by default you see this kind of UI. This is basically nothing but a kind of SQL engine, serverless SQL engine that is available to you. Simple. So if you go to catalog, we have no catalog. If I go to database, I can pick my demo DB. Remember we created this database. I can pick this, and I even have this table raw. So if I just want to write a SQL query, let's say select asterisk from raw, I want to query this, right? I can simply hit run and it should return me the data, and as I can see this is the data. How can I see this data? Because we already created this table using the crawler. Okay, yes, using crawler. So crawler automatically registered this data into this database. Okay, and now we are using Athena to query this data. So that means catalog is the central repository which is shared between AWS Glue and your Athena. Make sense? Just remember this thing. Simple. So I can even just write it for you. So Athena and Glue, they both are connected to the same data catalog. So you can either use Glue to register the tables or Athena, but under the hood both are connected to the same data catalog. Simple. Just remember this thing. This is very important. So same data catalog. Perfect. Makes sense? So now you can just query Athena, but you can only query through Athena. Same data catalog, and this is the query engine. Like not actually a real engine, but engine as in you can treat it as an engine. Make sense? So that you can just mimic this thing in your mind, how you can just query the data, right? And this will be connected to this thing. Perfect. And you always hit this particular SQL engine. Make sense? Ansh, Lamba, how do you draw these graphics so easily? So user hits the query engine. Query engine is connected to, like Athena is contributing to this query engine, or you can say it is connected to Athena, and same data catalog is connected to Glue. Make sense? This is the example. This is the flow. Make sense? Good. Now we will do some testing, some exploration within the Athena. So what I need to do now, I want to create new tables. Okay, if I click on create, I have many options. Create table as select, create table as this. These are basically the standard SQL way of creating the table, but I want to use S3 data, right? I will click here. So table name will be, let's say, new table, right? And choose an existing database. Yes, demo DB, perfect. Data set. Now we need to pick the data. So data, let's say, is raw, let's say, and just forget about if you see some new folders here, maybe I would be testing something. So if you see 1 to 2 new folders, so do not worry about that. Okay, so choose this one. And what type of data is it? It is in the, and let's try to build a table on top of this thing. Let's say delta packet. Okay, so processed. Perfect. And this is, where is our delta? Apache Hive, Delta Lake. Perfect. So this is the Delta Lake table. Make sense? So this is the query that it has generated for us automatically. Very good. Very good, very good, very good. And just a disclaimer, if you try to, let's say, pick any other table, any other format, let me show you, let's say CSV, let's say this one, right? This raw. So do you know what it will do? It will simply ask you to provide the fields. See, add a column, bulk add columns. So obviously no one adds column one by one. We always add column in bulk. So I will click here, bulk add columns, and I can simply provide a kind of tuple, or not even like tuple, but you can say sequence of columns. So let's say column number 1 is order ID, and it is of integer type, then space, then integer, int, then comma, then second thing, then third thing. So you can actually do something like this as well if you want to. If you have like CSV table, if you want to build CSV table, makes sense. But I want to build a table on top of delta, so I do not need to do this. But if you do not have a delta table, and if you want to create the table manually, you have to do it like this. Remember, I told you that crawler is much faster and I prefer crawler. That's why I was saying that crawler is a better way to do it. So I will simply say delta lake, perfect, Apache Parquet, perfect, because file format is Parquet, that makes sense. So this is our code, right? If I click on create table, it will simply run this command and my table is created. If I now create, see this thing, I can see new table as well. And this is the code that it has written automatically for me. So basically what it does, it creates an external table on top of your S3 data. Makes sense? That abstraction layer. So let me show you. So here, let's say you have your Athena. So now how Athena behaves, you have your data in the form of S3, right? So it will simply create the external table here. On top of, let's say, and we have the delta table. So let me just pick the delta table like this. So it will simply create the delta table for your file, and my file is in the delta format like Parquet, right, like this. So it will simply do this thing. So it will create external table for my delta table. Make sense? And all the code, everything will be written by AWS. Simple. External table, that means this table is not a table that you have created with the SQL thing. This is an external table where data is stored in the data lake. Make sense? So this is the external table created on top of this data. So actual data is sitting in S3, real data. This is just the metadata. This is just a table definition. That's it. Make sense? Okay, perfect. So this is the flow. This is the flow. Make sense, make sense, make sense. Okay, so now what we can do, this is already done. So now I can query it, or I can even save this query if you want to. So you can even save this query, save as query name, let's say DDL demo, right? If you want to keep it with you, you can save this query as well. And then you can say recent queries, saved queries, you can pull those queries as well. See, DDL demo and all those things. So this is a better way to manage the things. So now I will go to query 1 and I can simply say new table. Let's try to run this. So currently it is running and we can see the data perfect. And now this data is the transform data. Make sense? And this data is in the delta format. Make sense? Okay, very good. So now, yes, we are seeing order date. Maybe when we were just modifying our glue pipeline, so maybe we would have selected this column as well, but it's not a big deal. You can remove it later on as well. Makes sense? This is your Athena in a nutshell. This is very simple, I know, because this is pure SQL. People who know SQL, they already know Athena. There's nothing special, nothing new. Yes, this was a new thing that you already know. Make sense? Very good. Now, if I click on these 3 lines, right, and if I want to, let's say, create a table, or let's say S3 bucket, I can also create a table using crawler. So you have, yes, you have an option to use crawler from Athena as well. But you know what? The funny thing is, when you will click here, let's say open link a new tab, it will take you to the Glue. See, this is under AWS Glue. See, so they have simply embedded the link to Glue crawler. So crawler is inside Glue. Make sense? Very good. So to my knowledge, I would say you should always use Athena to create the tables using, I would say, for Delta. Okay, and in the real world we prefer creating the tables for Delta, or you can say those lakehouse fields. If you want to create tables for other data types, you should always go with crawler. Make sense? So this is your complete AWS masterclass, where we have defined everything, and especially in this Athena, we covered like Athena and all, query which is already there. We queried the table which was already there, create a new table. I'm just simply checking the list. Create a new table for S3 and define column schema. We did it. And create a new table with crawl. Yeah, we did it. So now we have covered the entire AWS masterclass, and I hope you would have found it useful. You would have found it insightful, and I know that you need these notes, and I hope like you would have already access to this particular notes. And how was the section? Just do let me know in the comment section. And if you just want to grow and do something in data engineering field, this is the channel for you. Simply hit the subscribe button right now and click on the video coming on your screen right now. I'll see you there. Bye bye.